Welcome everyone to the NGIatlantic.eu and National Science Foundation EU-US networking workshop for our Open Call 4 and also introduction to Open Call 5 discussions. You're very welcome here with us today, and our agenda is broken down as follows. We'll first have a welcome from the European Commission, the National Science Foundation, and then a very quick overview of the Open Call 4 for myself. And then we go into more detail on each of the topics within the Open Call, where we will just give a brief introduction on the topics, and then have speakers in each. And then if anyone would like to contribute something, and there's time left, you can raise your hands, and we'll try our best to fit everyone in. So we'll start with the EU-US experimental platforms interconnection, which is one of our most important topics. And then we have 5 new or 3 new NGI topics that we're covering in this call for EU-US experimental platform interconnections. And then we have 2 topics which are carryovers from the previous call, which we're pleased to have again in this open call. And then we'll have a short coffee break, and then we'll have our 5th topic, and then we'll have a specific session to already kick off our discussions about the Open Call 5 topics, in which we already have kicked off some discussions with the NSF. So with that, I would like to welcome George Gassos, the NGIatlantic.eu project officer from DG Connect Unit E3, to give us a few words. Thank you, Jorge.
Thank you very much, Jim. From my side, just a quick welcome to all the participants. For us, for the European Commission, this workshop is important since it is a first step in the reinforced collaboration with NSF. This is a collaboration that we started already many years ago, mainly in the fields of networks, connectivity, and experimental platforms. In the last years, already many years, through the FIRE initiative, we have been linking the experimental platforms testbeds in the EU and the US, and we have run a large number of joint experiments. And now NGI Atlantic is continuing these activities and is bringing together EU and US researchers to run joint experiments. NGI Atlantic has already mobilized the research community, and in the first phase of the project has achieved quite impressive results in bringing both sides together. And now a new phase has started recently with the Dear Colleague letter from NSF that is supporting the participation of US partners into these projects. And apart from the financial implications, what is more important to us is that we are now closely collaborating in the definition of the priorities, in the promotion activities, selection of projects, etc. And this workshop is an example of this enhanced collaboration in order to define the priorities for the next calls. As for the future from the European Commission, we are happy to announce that we have secured funding to continue these activities once NGI Atlantic project will be over. So, and we have secured funding for a new project that will start once NGI Atlantic finish and will last until the end of 2025. So this ensures a medium long-term collaboration in this area. In the project that we will launch afterwards, the collaboration will not be limited to the US, but it will also be possible to establish it with Canada. So this will also enlarge the possibilities for collaboration, and this will provide new opportunities for the research communities. And from my side, I don't want to take more of your time. I mean, the main focus of this workshop is your discussions. So I am just looking forward to see your discussions and the priorities that you will identify. Thank you very much.
Thank you very much, Jorge. Now I'd like to invite Mehdi, the Program Director for the Directorate for Computer and Information Science and Engineering in Computer and Network Systems Directorates at National Science Foundation.
Hello, everyone. I'm Deep Mehdi from the National Science Foundation, and I'm with the Directorate for Computer and Information Science and Engineering, in particular within that, the Computer and Network Systems Division. And within that, I am in handle the networking research program at National Science Foundation, along with research infrastructure programs. And Jorge, my colleague from counterpart from European Commission, already hit on a couple of important things that we have been collaborating on USU joint activities. And in fact, that goes back to a few years back when we did the ICE-T program from the US side. And with this NGIatlantic opportunity, we have actually now been able to create a Dear Colleague letter that was announced in February. Dear Colleague letter usually referred to as a DCL. Usually the researchers in the US are familiar with DCL. And DCL is used for many different purposes, but one of them is to be able to indicate any new funding opportunity that goes in as a supplemental fund for an existing active US NSF grant you have. And then you find a partner from the European side so that the European side submits under the NGIatlantic program. And then on the US side, you submit that within a week after the deadline for the European side as a supplemental request, and you then put a bit of information about the activities. But one of the requirement is that you basically attach the document that you submitted to the European side. So if you Google DCL, NSF DCL 21-048, you will find that. And so it got activated at open call number 3. That was in February. And so, that's in the process of being finalized and selected. And then there's no difference in the evaluation process between the proposal, between the partners and what it is said here. And then we are, looking to fund that once that we are actually, identified through this process of who, going to be selected. So, for example, we are not going to fund somebody on the NSF side if you do not get selected for funding from the European side. That's the whole intent of the collaboration. And so, again, the link is there on this particular page, and that was for the open call number 3 that happened. Now, as you know, open call number 4 is just coming up, and I believe open call number 4 has a deadline in September 15th, I believe, right, Jim?
Yes,
yeah, so that means a week within that is the September 22nd. So US side, you have to submit a collaborator on the US side on that. And we have identified a few priorities under open call number 4. And it's slightly different than what we have with open call number 3. And the other thing I want to add to that is that we have a number of different platforms that, even if you do not get funded, that you can use it. And those are like available for researcher. First one is NSF Future Cloud Platform, like Chameleon and Cloud Lab. That's free for anybody to use it. That's already pre-funded in a sense. And so you can request that. For that, you don't need any funding to use it. You can have a collaborator work with it. But also you could request might want to use it as a part of your open call submission. Fabric is a new platform. Anita Nikolic is going to talk a lot more about that, and that's just being kind of launched in terms of the demo part of it, and the first phase of the networks is going to be available later this year. And so it's not going to be ready for open call number 4. By open call number 5, we have to we hope to have it being more accessible for that. Second thing, Fabric has an international opportunity part of it, international collaboration extension to CERN in Europe all the way. And so again, Anita is going to cover that part later, but in talk. And then we also have Scott Schenker from UC Berkeley is going to talk a little bit about a new idea he's looking at called Extensible Internet. And that has a promising role of being able to use Fabric as well down the road. On the wireless side, we have a number of platforms: Cosmos, Powder Renew, and then AirPo. And in fact, the fourth one related to digital agriculture and wireless domain is, I think, officially going to be announced in about 3 days. I think, so I cannot say it who it is. And so, but look forward to that one to be able to also collaborate on that side of it. So I believe I'm going to stop it here unless Jim, any quick question that I need to answer at this stage.
I guess just on this slide, there were a number of the International Research and Education Network connections.
Right. Let me quickly add it. Good. I mentioned about ICT. That was the previous program. That's not valid anymore. We funded a number of projects under that when 2017, I believe, when it started, announced. IRNC, International Research and Education Network Connection. That one is allows you to extend connectivity to outside the US. And in fact, Fabric Across Border, FAB is one of the ones that got funded under this program. And that's what allows for Fabric to be reaching all the way to CERN, as I said earlier, and to South America, to Chile, because we believe from a scientific point of view, we have this important need in terms of a lot of data being needed to be transferred between the telescope at different places around the world. And if you're probably familiar with it, April of 2019, the first black hole image came out, and that was from collecting data from 6 different telescope locations, including one in Europe. I think it's in Spain, I believe. And so we believe with the next generation of the Event Horizon telescope, the need and the push for the amount of data and to be able to go in a faster way, not only that, with in-network computing and storage is going to be extremely important. That's why the International Research and Education Network Connection is a very important endeavor from the point of view of NSF. So yeah, already I said the open call number, 4 is on September 15th. And so and open call number 5, we're going to announce it when it's going to be ready. And again, the topic might be slightly different from collaboration number 4. And we continually talk between the US side and European side to identify what's of importance. Thank you.
Thank you very much, Pete. Very, very enlightening. And of course, we will share the slides with everybody. Okay, so just from my side, before we jump into the topics themselves, I just have one slide here about the just to kind of give you an idea of the topics. So similar to our third open call, we decided to have 2 different categories. One is allowing for the EU-US experimental platforms interconnection in order to have the different platforms, and it could be large scale or they could be smaller or medium-sized scale platforms interconnecting, for the purpose of enabling the innovators to run experiments on them. And then the second category is the running experiments with the key enabling technologies such as IoT, AI, and many others in 5 NGI topics, which we have here. So the NGI topics largely map with the NGI topics, obviously, in the NGI initiative. And these are the topics where results are showing which then can be used to run experiments with some excellent US teams. So the three new topics in Open Call 4 are Open Internet Architecture, Renovation, Service and Data Portability, Internet Data Sharing, and Interoperable Services. And then in our previous open call, we the project's Sflab that was working on strengthening internet trustworthiness with electronic identities had open call projects with some with good results. So they were included in our third open call, and then we're having them also in our fourth open call. And then we have a new topic or a topic in Open Call 3 on greening the internet, a sustainable and climate-friendly NGI, and we're carrying that over into Open Call 5 as well. The Open Call this time around foresees only one type of proposal, what we call the short term, but they could be anywhere between 3 to 6 months duration. And the funding levels are 25,000 to 75,000. So we're looking to have anywhere from 8 to 12 approximately projects being funded with a total budget of 600,000. Okay, so with that, we'll move straight into our second session, which is dealing with the EU-US experimental platforms interconnection topic that we have. So as I mentioned, this is for the twinning of EU and US established designers and facility providers of experimental infrastructures, testbeds, and platforms. And it's with the purpose of enabling the experimentation in the NGI areas on both sides of the Atlantic to interconnect with each other, to offer their facilities on a continuous basis to its community of experimenters and application developers and any NGI-related topics. And one thing that we have made clear is that for the ones putting in the applications for this particular aspect, that it would be expected that the facilities could be used for experimentation of NGI projects, either ones running at the moment or ones in the future. And of course, if there is new work in maybe the next open call and they want to join an applicant in a new project, you can of course do that and avail of getting funding to do that. So it's it wouldn't be expected to for you not to be compensated for your efforts in there. So we're very happy to have today Ms. Anita Nikolic from the University of Illinois at Urbana-Champaign to tell us about the Fabric platform. Anita, are you there? Robin, can you tell me if Anita is on the line?
Yes, just a second.
Jim, I thought she was on the schedule in the after at
Okay. Oh,
10
sorry.
o'clock.
Okay,
Right.
no problem.
That's what I indicated to her.
That's fine. Yeah,
okay.
I actually have her in that session as well. For some reason, I thought she might be doing both, but
No,
I think I took you up wrong, Deep. I'm sorry. It's my mistake. So with that, we'll have Brett Vermeulen from iLab.t test lab, and he'll present for us the Fed for Fire platform. Thank you, Brett. Do you want to?
Yes, hello, good afternoon.
Share screen? Okay.
Let me share the screen. So, welcome everyone. Thanks for inviting me for this presentation. So, I'm Brecht Vermeulen. I'm affiliated with IMEC, which is a research institute in Belgium and Europe. And I'm also the technical coordinator of Fed for Fire. So, Fed for Fire is a European project about federating existing testbeds or experimental infrastructure in Europe. And this short talk, I will try to illustrate what Fit for Fire is about. So we started in 2012, so about 10 years ago, with a number of testbeds which were already existing. So the project itself did not build any testbed. We only federated existing testbeds over there. And as you can see with the colors, we indicated a bit what the different technologies are that each testbed supports. So it's going from wired networking, wireless networking, IoT, cloud, big data things. So it's a big variety of testbeds. And every testbed has also its own technology. So that's a bit different from the infrastructures that were built in the US, where you typically have like a big rollout of one technology, one kind of infrastructure, for instance, Instagini, Exogeni in the past, Fabric, Cloud Lab, over multiple sites. Here we actually started with testbeds which were built before we started Fit for Fire, and the testbeds are typically used for internal research by, for instance, universities. So that makes that every testbed has its own features, its own technology as well. So it's a very diverse field to play with. So of course it's real infrastructure. So on the left top you see, for instance, a wireless testbed also with some mobility in there, with Roomba robots who can which can drive around in the room, but going also to GPU kind of cloud infrastructure. So a very big variety of infrastructure. And there's a portal.fitforfire.eu. So actually it's open to anyone for using, a bit similar on what Deep told about Cloud Lab. So they are actually pre-funded as well. So it's open access. People can ask for an account and start using it. We have also an interesting filter on guiding you in which testbed could be interesting for you to use. So that's a bit on what is available. So what was now our goal? Because of all the testbeds having their own history, they also had their own account system, their own tools. So what we did is with the federation, we tried to make it easier for experimenters to use those testbeds. So by, for instance, only having a single account, a small number of tools, you can actually access the different testbeds. And then why would you use multiple testbeds? There are diverse reasons for that. So it can be to scale up your experiment, which is a straightforward reason, of course, if you want to use more resources, but also to compare. For instance, if you're doing a wireless experiment, you want to compare different environments. So maybe your algorithms, your experiments behave different in different environments, and you want to check that in different testbeds, for instance. Redundancy, if a testbed is down, you just use another one is also a typical reason, or having specific resources. So that's the underlying thing. Of course, all testbeds are usable remotely. Certainly through this pandemic, this is very interesting. And for instance, what you see here is you depict multiple clouds on the testbed. You interconnect them with some advanced networking, and you can build your own, well, Google in the lab, so to say. We do not only federate with testbeds in Europe. Actually, we federated also with Genie testbeds, also with Cloud Lab, Exogeni, and so on. And you see, so today with your Fit for Fire account, you can actually have access to the testbeds depicted on this map. So it's actually much broader because of existing collaboration with EU, US, EU, Brazil, for instance. You can also access testbeds over there. So that's interesting to know as well. Just to give you an impression on the user tool JFET, which is used, so you can actually draw your own topology. So each box here is, for instance, a Linux node or a wireless node that you can use. And so you can build up your own topology easily with that. So as I said, it's already open access. So you can use it, especially for research. can have free access. It can be that for some testbeds, it's a limited use of resources, limited support also. But anyway, you can use them. We do also have open calls. So if you are an SME, you can also have access over there, or for instance, through the NGIatlantic open calls, of course. To give a small example of something we did cross ocean is that was some years ago, where we set up an experiment between multiple testbeds at US and EU sites. So it was at the Genie Engineering Conference, some demo there, where we had a triangle connections between a software-defined exchange in Ghent, Belgium, Washington Exchange, and also Cloud Lab through Internet too. And then we had also some Genie resources, some European testbed resources, where we added more things. And this was for distributed video service, where we had some backends with some video caching, and then we used other testbeds to generate client resources. So just to give you the idea of this kind of experiment is possible. This is not that straightforward. It might need some support from us, because it's a very complex setup, but it is possible. And certainly with upcoming things like Fabric, this should be more straightforward to set up. That's how it was built. Just you start with a small backbone to test functionality, and then you can easily add resources to scale up. So this gives you an idea how what is possible and how you can build such kind of experiments there. And that's then, well, in the end, you of course measure things like bandwidth, or you break one of the links, you look at redundancy. So that's then your real experiment, of course. So that was a short introduction. As it was already mentioned before, there's now a possibility where you can have funding at both sides of the ocean, EU and US. And the infrastructure of Fit for Fire can be used. So if any interest, you can of course contact me. You can also have a look at the documentation of Fit for Fire, or you can even just create an account to test a number of things. So it's up to you. So that's my last slide.
Thank you. It's very, very interesting.
Hi, Jim. Sorry, I think there's a question in the Q&A chat asking which testbed have GPU availability.
I'm sorry. What was that again, Ruben?
There's a question in the Q&A chat.
Yes.
That it was written while the presentation was going on, and they're asking which testbeds have GPU availability.
Okay. Brecht, did you hear that question?
Yes. So it's called GPU Lab that has most of the GPUs available. So if you go to doc.fitforfire.eu and look for GPU Lab testbed, you will. Yeah, it's actually working with Jupyter Notebook, so it's a very high-level interface to use it. So you can start straight out of the box.
Okay, thank you. There was just a question there, but I think Caroline has answered it. You know, what exactly do you mean by testbed? I think it's been answered.
Yeah, well, testbed, it was, I think, also answered. So it's actually resources. So maybe let's share my screen again to really show this. So these are all testbeds. So you see, for instance, this one is just plain servers. It's, I think, also similar to, for instance, Cloud Lab in the US. So you have like more than 500 servers where you can deploy Linux on it, and you can instantiate a number of them. So suppose that you want to build your own cloud and you want to instantiate 10 servers. You have bare metal access, root access to them, and you can deploy every software you want. This is an example of a wireless. So there you have actual wireless access points, wireless clients that you can configure, and you can do, for instance, a scalability experiment on the wireless spectrum. With GPUs, you have access to the GPUs, and for instance, with Jupyter Notebooks, you can process some data. So a testbed is actually a collection of physical resources doing that for you. So I hope this answers a bit.
Thank you, Brecht. And I can also see that Marek Mikhailovic just is raising his hand. So let me see if that question or... Hello, Marek?
Yes, hello. Hello, everybody. I have a question for Brecht. His second last slide with this one. Could you explain what the percentages mean? Because the kind of 0%, it doesn't look of what?
Yeah. So it's the percentage of the link bandwidth that was used. So you see, for instance, this was during days on the European side. So you see that the links towards the clients is about 98% loaded, while the links towards the clouds providing the video services were still not fully loaded. And of course, the US people were sleeping and were not watching any video at that time. So that's a bit what you see.
Look, but I have a question for the transmission technology. Are those links TCP/IP, or could I go to, for example, I have ideas for testing Rocky at very large distances, or I would like to have a dark fiber with InfiniBand. Extended range InfiniBand. Could those sort of things be done on that testbed?
So in this figure, all the links were layer 2 links Ethernet. Some of the testbeds do indeed offer InfiniBand as well, but that will be limited in the testbed, of course. So depending on your needs, you can see what is needed, but okay, we try to get it as low level as possible.
Okay, so I will send you my email, and perhaps if you don't mind, I would like to talk to you about that.
Yeah, no problem.
We see on you have this Atlantic thing, but I'm developing collaboration with Singapore, Australia, Japan, going different ways. So if I would be very interested in pursuing that or joining.
Sure.
Thank you.
So my email is on the slide here.
Okay.
Thank you, Marek. Thank you, Marek.
Yeah, thank you very much.
I see also another question on the GPUs. I will answer it in the chat with some links.
Okay, thank you. Okay, so I would suggest that if anyone is interested in this particular topic, you might want to make contact with Brecht. Help you with that. Okay, so with that, I will take back the screen. Okay, so now we move into the 5 NGI topics. And the first one we're going to cover today is the Open Internet Architecture Renovation. There's a project called NGI Pointer, funded by the NGI initiative that is funding open call projects in this area. So what's on our open call platform about the topic is that it will focus on experiments supporting communities of developers and ensuring internet architecture evolution towards better efficiency, scalability, security, and resilience. It will also look at auditing, testing, and improving protocols and open source software and hardware that's used to manage the internet with renewed design goals, isolation of contingencies, redundancy, self-repair, and the ability to roll out at internet scale should be assessed as part of the proposed solutions. So again, just let me emphasize that the NGIatlantic.eu projects are looking at running experiments of results in these topics as opposed to the research and innovation of these topics. So you'll be taking the results and then teaming up with a US partner to run experiments in these. Okay, so the coordinator of NGI Pointer, Mirko Presser from Aachen University, unfortunately couldn't be with us, but he was very nice to provide a video for us. I hope you can hear the video okay. Let me try it again.
Jim, we can hear it, but you can try on the bottom left side of your screen. There should be the icon of your microphone, and there should be like a small arrow pointing up next to it. If you click it, you can choose like select a speaker, select a microphone, and you should have like something like a system audio or.
I'm sorry, I just somehow got lost here. Am I still on?
Yes, yes, yes.
Okay, sorry. So where would it be?
Or probably you have a floating menu.
Yeah,
like
I have
like a bar. Yes, and there should be like the icon of your microphone.
Yes.
And next to the icon, there should be like a small arrow.
Yes,
pointing up. That. If you click, you should have like different options.
Yeah, microphone, same as system.
Yes, same as system should be fine.
Okay. Sorry, just give me a moment. I'm going to have to try to find that that link again. Okay. Share my screen again. Okay, can you see my screen?
Yes, we do.
Can you hear?
No, it's very strange.
Okay, hold on. If I send you the link.
Yes, I can. Yeah, definitely I can stream it. Yes.
Okay. All right, I'll send it to you in the chat.
You have to still check your floating menu.
Just give me a moment. It's a very long link.
Yes.
Did you get it?
Yes, I do. Loading. Let's see. Let me load it first. Okay, can you see it?
Yes. No, I can't hear. No.
It's very strange. Unless it doesn't recognize the system. Do you have it offline? Like, because I can see it. It doesn't allow you to load it.
No. It's okay. I think we'll just move on. We don't have too much time. 。
Okay, if you want to go ahead, I will try to find a way to download it, and maybe you can share it later.
Okay. All right. So just okay. So we're very happy to have Professor Scott Schenker here with us today from the University of California at Berkeley, ICSI. And he's going to present for us the Extensible Internet, EI. We would thank you so much for getting up so early, Scott. We really appreciate that. So do you want to take over the screen?
Yeah, please. And
Okay.
and what should I head for in terms of timing?
I think you're good for the full presentation because we're actually ahead of schedule without the video. So
Okay, so I'll shoot for about 20 minutes.
that's perfect. That's
okay.
absolutely perfect. Thank you.
Okay, great. So as you know, my name is Scott Schenker, and I will be talking about the Extensible Internet. This is based on a very recent CCR editorial with 18 authors. I'm not going to bother reading all their names, but the core design team consists of myself, along with Karvin Krishnamurthy, James Macaulay, and Orjit Panda. And so this will just be a very short introduction to this, and hopefully we can get into more. And you know, the title of this session is Architectural Renovation, and I want to ask the question of renovation or revolution, because I've spent a lot of my career doing clean slate internet designs, and all of my proposals, at least, and I think more broadly in the community, these proposals for comprehensive architectural change have gone nowhere. And so, you know, I've asked myself, should we or I just give up trying to make this kind of change? And being pretty stubborn, you know, the answer is no. But before sort of continuing this, I think it's really important to understand why is the internet so hard to change? And the answer, I think, is more subtle than I had first imagined. And then what can we learn from the new private networks that are arising all around us? You know, from the Amazons and Googles and Azures and the like, because they've obviously been able to accomplish something that we haven't been able to do. And the key recognition for why the internet is so hard to change is to recognize that layer 3 has two very distinct roles. One is that it allows all layer 2 networks to interconnect. That's what layer 3 was invented for. And so it must be deployed in every router, and you know, becoming the narrow waist. And then it's almost impossible to make significant changes to this protocol IP because it's in every piece of hardware, basically. But the second role is it provides the service model to the host. That is, the best effort packet delivery that these routers support is what hosts see. That's what they think of as the network. That's what the network is providing. And this must be good enough to support all application requirements, because that's what the internet supports. And these requirements are becoming more stringent for a variety of reasons, either new applications like robotics or just the financial implications of increased latency on ads have meant that we're going to have much more stringent requirements on latency, on reliability, and now privacy and security. So these requirements are becoming more stringent. So we've got a paradox that the first condition is telling us we can't make any changes, and the second condition is telling us we must make changes. And so the conundrum we're faced with is, how can the network meet more stringent application requirements without changing IP? And there, I think we really need to look at the lessons from the cloud and content providers, because they're building these large private IP-based networks with many points of presence. And in these points of presence, they're deploying these sophisticated in-network services. Flow termination, caching, load balancing are the most popular ones. And these have definitely improved application requirements, in particular, increased reliability and decreased latency significantly. Now, this is definitely good for those applications, but I claim that it's bad for the internet. And that's because the internet is becoming increasingly balkanized. And what I mean by that is the private networks are now defining their own in-network services. So they're different from each other, and they're leaving the public internet, by which I mean the end-to-end IP service that a carrier would provide, they're leaving that behind because the carriers don't control the endpoint, so they can't just insert these services in between. And so our contention is, rather than go with these ad hoc and proprietary designs, we need a coherent architecture. And we don't need the architecture for academic reasons, just for it to be intellectually coherent. We need it because only when you have a coherent architecture that's agreed upon and understood can you broaden the set of in-network services. And I'll explain why that's true later. And also, when you have a coherent architecture, this becomes the new internet service model. It doesn't just be, it's not just a proprietary design. It actually is the universal internet service model that the internet would adopt. So that's why we want to go from these ad hoc and proprietary designs to a coherent architecture. So our proposal is the Extensible Internet, or EI. It uses the current IP protocol and infrastructure unchanged. So all the current routers are unchanged. It introduces a new network layer above layer 3. We call it the service layer, SL, or layer 3.5. And this service layer offers new in-network services to hosts. That is just like these private networks that offer things like flow termination. That's what the service layer is going to be doing, is offering these in-network services like the current private networks, but much more. Now, the key here is to recognize that EI decouples layer 3's two roles. The current layer 3 is the interface to both layer 2 networks, so it must be the narrow waist that's in every router. And it's also the interface to layer 4, so it defines the internet service model. In EI, layer 3 is still the interface to layer 2 network, so it's still in every router, it's still the narrow waist. But the service layer is the interface to L4. And there is no reason for this service layer to be narrow, nor any reason for it to be in every router. So the proposal is to make the service layer, have it be implemented at service nodes. And service nodes are just servers that are deployed at the network edge. By edge, we don't mean any sort of specific location. We really mean it's close to hosts. Whether it's in central offices or cell tower or just back at some aggregation point, doesn't really matter in the beginning. Every host is associated with one or more service nodes. And the service layer is also obviously implemented at hosts. Hosts have to implement all the layers. And the typical communication pattern then is when a packet leaves a source, its first hop is to the service node that it's associated with, and then it goes to the service node associated with the destination, and then it goes to the destination. At the service layer, these communications are tunneled over IP, so you use a pretty standard tunneling protocol. And the main requirement of that tunneling protocol is it allows the source to specify which service to invoke when it gets to the service node. So the service node supports multiple services, but the source tells the service node which service to invoke for this particular communication. So here's just a diagram. It doesn't really contain anything I haven't said already, but you can see that close to any host, whether it's in a home or office, whether it's cellular, whether it's autonomous vehicles, or in a cloud, there's a nearby service node. And if you're going between any two hosts, you go to the nearby service node of the sender, and then the nearby service node of the receiver, and so forth. So all these services are in software. The standards then are open source code. They are not detailed specifications, and that's actually important. And the necessary software pieces on the service nodes, you first have the standardized service model. That is, for any service, and I'll talk about what we mean by a service, but for any service, you'll have a module that implements that service. And it will run within a standardized execution environment. That is an environment that offers a set of simple primitives like packet in, out, read-write ephemeral storage, read-write stable storage. And that simple execution environment is write once, run anywhere. So you don't have vendor-specific execution environments. You've got this completely standard execution environment in which service nodes run. And then you have runtime and orchestrations, and these will probably be open source, but it could be anything from Kubernetes, OpenStack, or even various clouds if they've got their own proprietary runtime that handles scale up, scale down, failure recovery. That doesn't need to be standardized. Now, these services don't involve a lot of computation. So this is not edge computing. These services really involve packet forwarding, that is, where do you send the packet? Payload processing, aggregation or compression, and simple functions like caching. So they're really quite simple, so that they're not computationally intensive. And the kinds of services we're talking about are the basics like flow termination, caching, and load balancing that these private networks already do. Support for other delivery models. We know that multicast or pub/sub, which is not end-to-end available in the global internet today, these kinds of things will be very valuable for applications, and they can be easily built on top of EI. Redirection services that might take you to the closest edge computing service, or even QoS. And here, I'm not talking about intserve or disserve, that these service nodes can actually act like SD-WAN boxes and pick the available technology for you that meets your needs. Support for various use cases. Obviously streaming dominates the internet now. You could imagine services that are specific to them, not application specific, but use case specific, or IoT or gaming or AR, VR or autonomous vehicles. And we know that we need help in security and privacy and things we know we can build on EI, things like denial of service prevention, attestation so that when I access Google, I know that I'm talking to a Google node that is running Google attested software. Privacy, we can do things like ODNS or Tor. And then radical architecture. So in both EU and the US, there was a lot of research on clean slate architectures, which were very hard to deploy, things like information-centric designs. But these can all be deployed on EI because they fit this model. And in particular, ICN designs just look like using caching for a particular form of naming, that it would be very easy to deploy that on EI-based design. Now, how do we choose these services? There's going to be some governance process, probably very much like IETF, that determines the set of public services and their implementations. These public services are deployed on all service nodes. That is, if you claim to support the internet, then when there's a new approved service, it must be deployed. And that's easy because it's write once, run anywhere. And so these set of services form the new internet service model. They can also offer private services, which I won't get into now. But the point is, because these applications explicitly invoke these services, they don't need to be backwards compatible. In the current private networks, they must be backwards compatible. But here, we can offer multicast because you wouldn't ask for it if that wasn't what you wanted. So these services can be added extensively, by which we mean adding a new service doesn't break anything, and if you know about it, you can use it. So interdomain routing in the service layer, I don't want to go into this in detail, except just to tell you that where we ended up is that in the service layer, packets travel directly between the source and destination domains. At the service layer, there are no transit domains. Moreover, the peering is not only direct, but it's settlement free. Probably not here, but you can get me started on a rant on why this has to be true. It has to do with network neutrality, but we think it would be important to bake this into the design. Now, the actual at layer 3, the packet delivery between service nodes can be done the way layer 3 does routing, whether it's normal L3 routing or using an IXP as an intermediary or a direct connection on leased lines. So the summary of the EI proposal is we're not replacing IP at all. We're just inserting a new layer on top. So all the current infrastructure is unchanged. You can easily offer these new in-network services, just deploy a service model on these service nodes. It makes the internet truly extensible. So the internet becomes an evolvable platform. And the right way to think about this is, IP had to be a one-size-fits-all protocol. And a lot of the clean slate architectures, also adopted that of, how do we replace IP with another thing that will meet all the needs? And here, because it's extensible, what you need for every application, or actually not even every application, every communication, is at least one service fits its needs. These services don't need to fit everybody's needs. Now, EI is based on a simple conjecture that in-network support for applications is important for many current and emerging applications. It can be done at service nodes rather than at each router, and it can be done in software, not in specialized hardware. Now, these are conjectures, and we could argue about them, except we've got very strong evidence that they're all true, because this is exactly what the private networks do at scale and at speed. So that we've got running examples of this working in the real world for real customers, billions of them. So EI is merely the architecturally coherent version of what these private networks are already doing. Now, some people say, well, no, this isn't an architecture, it's just an overlay. And the only argument I have with this is the word just. Of course it's an overlay. The layered internet architecture is nothing but a structured set of overlays, of L2 over L1, L3 over L2, and so forth. And EI is also, but it's a very specific overlay. It dictates where it fits, which is layer 3.5 or the service layer, where it's implemented in service nodes, not in routers, and how the overlay fits into the domain structure, which is statements about peering and payments. So yes, it's an overlay, but it's a very specific one. And you might ask why, after at least all of my previous failures, why does this have a chance? And it's really, we have a new set of actors in the ecosystem. That is, these cloud and content providers that are really sort of driving the innovation in these backbone networks. And when you look at the sort of the players, the customers, the cloud and content providers, and the carriers, they all win. The customers get better service. The cloud and content providers don't have to now build out their entire infrastructure of these POPs. They can rely on the sort of what the carriers would provide. And the carriers win because they've been struggling to go beyond just packet delivery, and now they can have a much richer set of services. It's not a one-size-fits-all architecture, so we're not searching for the holy grail. We just keep adding services as their needs arise. And a key point here is software is fast enough. That is, we can deploy this because the private networks have shown us that running this stuff in software works. And the carriers already have plans for these edge computing deployments, so they're already putting racks of servers close to the edge. And so we're just leveraging what private networks are doing, and that's why we think it has a chance. The incremental deployment, it's not going to happen overnight. So the incremental deployment path is going to look something like this, and this is obviously speculation. Initially the service nodes will just be on test beds or clouds, not at the very edge, but somewhere close to users. And it'll be used initially for experimental applications, but then eventually sort of early stage applications that find some of the services like multicast or PubSub actually improve the service they can give users. And then as the applications begin to adopt this more seriously, and there's actually some commercial usage, the carriers might start deploying the service nodes more locally in their central offices or aggregation points. But this wouldn't be some wild stab in the dark. They would be taking software that's been already substantially tested for a couple of years and deploy it on resources they already have, which are these edge computing resources, with no change to the rest of their infrastructure. So that we hope that this deployment path, which is of course speculative, turns out. And you can also, while I've been talking about commercial adoption, you should also think about it as a research platform. That is, for researchers who are building services, you can design and deploy these services, new packet delivery services, new security services, using the test beds and the software infrastructure that EI provides. And for researchers who are building applications, you can incorporate our host EI support, which I'll talk about on the next slide. And real users can run these EI supported applications. They don't know anything about EI or the test beds. They just know that they're running an application that's got good performance. So if you're a researcher and you're interested in either services or applications, we'd love to talk to you. And the status is we hope to release the initial code or the infrastructure code at the end of this month. We're in discussions with test beds about early deployments. Sflab is our initial target, but we obviously would love to talk to others. We're seeking involvement from industry partners, whether that's cloud carriers, app startups, or others, for both advice and perhaps infrastructure. We will be reaching out to the community to hold workshops to talk about, what kinds of services do people think would be needed, what kind of applications need support, and how to build the infrastructure. We view our role as, our team as, we're going to build an initial version of the infrastructure, but we really hope the community chips in on building services and building applications. So we need your help moving forward. And if you're interested, please contact me. And thank you for your attention. And I think I used all my 20 minutes. So thank you. I'd be glad to take your questions.
Thank you very much, Scott. There's definitely very good food for thought for teaming up with EU partners in this open call, because the NGI initiative has, plenty of, startups and SME type partners, looking to team up with experimental platforms.
Hi, Jim. Sorry, there is a raised hand from Zhang. Do you it's probably a question?
Okay, I can't see it.
Yes, I am allowing him to talk. So, okay, now. Zhang, can you hear us?
I believe you're on mute.
Okay.
Same.
Well, I'm asking him to unmute himself, but okay, maybe we'll come back later. In case, Zhang, just write me a direct message or write on the chat when you're back. And also, I think I've downloaded the videos, the one who want to show you, want to show before. Do you want to share now? Or?
Can I before we go, can I ask a question to Scott? I think just for the interest of the group there. So the question is that one question is more, and a broader question is it going to, because you're thinking about a service layer at 3.5, is it going to look more like a overlay network in some ways? And how is it different from many different overlays network concept that has been around last 20 years or so?
Right. So that's a crucial question. The key is we've made specific decisions about at what layer we're inserting the overlay. We're making decisions about where it runs, these service nodes, and we're making decisions about how that fits into the domain structure. And so many of the earlier overlays like RON and so forth did not make those specific decisions. So this is really trying to not just say, well, we're going to run an overlay and an overlay can do whatever it wants. This is how can it be consistent with the way the domains interact now? How can you fit it in coherently? And also by having it become an official part of the infrastructure, by having these right ones run anywhere, how can you build a service model out of it? So yes, we're definitely building on the notion of overlays, but we're making it specific enough in a way that previous overlays did not make these same set of choices.
Great. I do have another question more on the going to the any kind of experimental. In terms of the code, the base that you need to develop. The first question is more on what the challenges are in the code base to develop, and what sort of initial things you want to kind of test or experiment out of to check out how the UI framework might work. Do you have some thoughts on that?
So the problem, the challenges we find in the early code that we're building now is, as anybody who's done networking software, is all the stupid little details you didn't think of the first time. You know, that conceptually it looks very simple, but then you worry about, oh, okay, now I've got a NAT, and what, you know, so what do you do when you're confronted with a NAT and you have to make modifications? So it really is, you know, pretty simple, except thinking through all those details is the hard part. And of course, we'll make this open source. In terms of early applications, we are heading towards, you know, we're writing up actually a design paper where it is sort of a pub sub service, an ICN service, an attestation service, and a denial of service prevention as, you know, and ODNS. So it's sort of privacy, security, and you know, different delivery models are where we're starting. But what we, you know, we understand that we don't have, that the community will have a much greater imagination than we do. And we'd love to hear from them.
And my final question, Scott, is that, I mean, if I set aside, you know, our typical bandwidth delay product type issues in a network, what sort of things you feel like from a wider international network that may span from, let's say, you know, like the fabric test bed could span from Japan to Chile to, you know, CERN in Switzerland, you know, kind of from a, you know, larger, bigger networks, you know, spanning a bigger geographic area. Do you see some interesting potential challenges in that space in terms of the EI?
Yeah, you know, I think for some of the benefits that the private networks got was from having the service nodes, their POPs, close to users. And so if we find that we're not able to get close to users, then we're going to have to figure out, you know, to what extent it's providing an advantage. But I also think that just, you know, it's a real mistake to build things where you have implicit assumptions baked in, like the round trip time is really short. And so I think that building something where there's, you know, wide varieties and bandwidth available and wide varieties of latencies is just a way to make sure that something like our pub sub design doesn't fall apart because of the different time scales.
Great. Thank you very much.
Thank you for the questions. And thank you, everybody, for listening.
Okay, thank you very much, Scott. It was really, really excellent. So I don't think we were able to connect up with Yang. So I'd like to move on to our next speaker, David Haushier. Let me just share my screen. But just before I start with David, I'd like to just point out that we have the video running, but in the interest of time, and I know David has to leave right after this, we can watch the video later. But I just want to point out, especially for Scott, that there's a number of these projects that are being funded by NGI Pointer. There's some of the attendees, including our next speaker, David, on the call. And so these have been up and running for about a year, and that they'll have some results. So I'm sure there could be some good synergies between the EU and the US with the EI work with you, Scott. Okay, so I'd like to welcome our next speaker, David Haushier from the University of Magdeburg. Works on the Scion Secure Internet architecture, which is a deployment of the next generation internet architecture. So thank you, David. If you want to share your screen.
Yes, thank you very much, James. Let me just share my screen. Okay, I hope you can see that. Okay, thanks very much, James, for the invitation to this workshop. It's my pleasure to talk to you today about the Scion Lab, which is the deployment of a next generation internet architecture. So some of you may be aware of Scion, a secure internet architecture that has been initiated by Adrian Perrig at ETH Zurich. Scion stands for Scalability, Control and Isolation on Next Generation Networks. It's basically a software-defined WAN approach with design goals that are very ambitious, including availability in the presence of adversaries like DDoS attacks, transparency and control over forwarding paths, multipath forwarding, as well as efficiency, scalability, and extensibility, and also deployability. What's important to remark is that Scion also provides incentives for deployment to overcome the resistance of today's internet service providers to upgrade the core internet infrastructure. So with Scion, ISPs have new opportunities for new business models and new services, and also the migration to the Scion architecture requires only minimal complexity and costs to the existing infrastructure. Now, to just tell you a little bit more about Scion in a nutshell, Scion is essentially a path-based network architecture that is enabling aliases that you can see on the right-hand side in the figure in circle, being grouped together in so-called isolation domains to construct and disseminate path segments on the control plane that you can see here in different colors. There are up path segments that connect ASs to superior ASs, so-called core ASs, with the gray ellipses, and other path segments in between core ASs that are called core path segments, and then down path segments on the remote isolation domains. Now, those path segments get disseminated, as I mentioned, and now on the data plane can be combined by end users attached to those ASs in order to build complete end-to-end paths. Now, all the packets that are being sent on the infrastructure then contain those paths, which you can see here in an example. So this is an example packet that combines the blue path segment here together with the orange core path segment and then the green down path segment on the remote side. The routers in between can then forward those packets based on those path information, and that makes the routers much simpler since they can operate in a stateless mode. Scion has really matured over the recent years. Its prototype software is now in its 5th generation. The Scion network has been in operation actually since 2014. A couple of ISPs have already implemented the Scion. NRENs are participating, and also several banks are already connected to the Scion network. So Scion is now indeed ready for larger scale deployments. What's interesting in this context here is that Scion contributes to several planned research activities in the context of NGI. Specifically, it enables research that would otherwise be only possible in simulated environments. For example, multipath communication, advanced and highly secure PKI systems, in-network DDoS defenses, and many more. One that I want to particularly emphasize on is the path-aware networking capability that Scion provides. And I believe it's a concept that once you have used it, once you have got in touch with it, you really don't want to essentially go without it anymore. Now, in order to give researchers the opportunity to play around with the Scion next generation internet architecture, we've built Scion Lab. Scion Lab is targeted on a fast setup and low entry bar for end users. It requires only little technical expertise to set up on your own a Scion AS in a very simple, intuitive, and automated manner. So in fact, Scion AS with our approach can be instantiated as a virtual machine in only a few clicks through our Scion Lab portal under the URL indicated here. There are multiple so-called attachment points to which users are then able to connect their Scion AS to. And we currently have more than 50 infrastructure ASs with over 600 user-created ASs in this network. The release updates are done automatically, and we've also provided image builders for various platforms, including ARM, for example, if you want to run a Scion AS on a Raspberry Pi, or also we have an Android port. Our work on Scion Lab has also been published in the ICMP conference and received the Best Paper Award there. Just to give you a few results on our Scion Lab network, you can see here the network latency inflation using one-hop communication in our network. And we can see that 83% of the node pairs show a tolerable latency overhead with a difference in the RTT compared to the legacy network with less than 5 milliseconds. But what's even more interesting is that using multi-hop communication in the Scion Lab network, approximately 33% of the node pairs actually show better latency than on the traditional internet. And I think that is quite remarkable. If we look at the path diversity that Scion Lab provides, then that's maybe not so surprising anymore. So approximately 60% of the paths in the Scion Lab network show an alternative path with a proportion of the delay of the alternative path to the shortest path of less than 1.4. Some of the additional work that we have done with Scion Lab is recently we've deployed Scion also on the FET for Fire Plus infrastructure that Brecht before was talking about. So in this context, we did a large-scale Scion deployment and evaluated it across multiple FET for Fire testbeds, including the Géant GTS infrastructure, Virtual Wall at Ghent, Grid 5000 in France, and also nodes from Exogeny. The goal here was to analyze the inter-testbed connectivity of Scion in terms of performance over native connections, because as a fact, today's infrastructure of Scion Lab is mostly based on overlays, but with this FET for Fire infrastructure, we had the opportunity to also evaluate that on a truly native infrastructure. And with our approach, it was possible to connect FET for Fire Plus testbeds with Scion Lab to enable experiments using Scion on those interconnected testbeds. And as such, Scion may actually even become a base network substrate for FET for Fire Plus, enabling multipath connections between those testbeds. Just to give you an example, for example, looking at the latency, we were able to explore different paths with delays of as low as 12 milliseconds up to 96 milliseconds, for example, to provide an alternative. And looking at the bandwidth, we were able, through multipath setups, to increase the bandwidth by a factor of 1.5. Other ongoing and planned projects that we are currently carrying out at my lab at the University of Magdeburg is in collaboration with NLNet in the NGI Discovery project. We are building a secure and reliable decentralized storage platform using the Scion architecture. Then we've also we also got funded for our work on RAINS, a name resolution system for the Scion architecture. Then in collaboration with DKIX, one of the largest IXPs in the world, we're currently also aiming to deploy Scion on Internet Exchange Point infrastructures. Then we have also work ongoing on P4, trying to hardware accelerate Scion packet processing. We are also working on traffic optimization via performance-based path selection, and in addition to that, we are also looking into monitoring mechanisms and incentive mechanisms for path-aware networks. One of the plans that we currently have, which is interesting in the context of NGIatlantic, we're also in contact with NSF Bridges, and the plan there is to connect or to run a Scion Lab over it in order to enhance the path diversity across the Atlantic as well. You may be aware that Bridges is currently building up a infrastructure with two 100 gigabit connections over the Atlantic, and this would allow Scion Lab also to connect to Internet 2, to the Fabric testbeds, etc. One particular project that we are currently working on in the context of Scion that I would like to mention is on secure Internet of Things with Scion. I guess you're all aware of Internet of Things. I don't need to explain that further. And I think you also agree with me that security is really one of the biggest concerns in adopting IoT technology, especially in enterprises today. Now, fortunately, with Scion, we can address many of these security concerns. So, for example, critical infrastructures as they exist in transportation or the power grid, etc., which have very high availability requirements, those can be met with Scion thanks to its ability to overcome potential failures and attack on the infrastructure. Also, unauthorized access to IoT devices that often have weak authentication mechanisms, like, for example, in smart homes or healthcare devices, can be prevented with Scion by completely hiding paths towards them. And also, thanks to path control, we can also address privacy requirements like they exist, for example, in healthcare applications by doing geofencing, so by keeping traffic in selected areas. We are currently working on a smart metering use case where we demonstrate several of these properties, and we've also published this work in context of the IM conference recently. So I hope that I could generate your interest on the Scion Lab network. If you wish to join, you can either do so as a regular user AS. This is especially if you are wanting to run or try out Scion by running some research experiments with a full-fledged Scion AS. Our infrastructure allows you to connect really quickly and with only a few clicks. And so if you don't have any specific hardware available and just want to run a user AS in your laptop, for example, with VirtualBox, then that's the way to go. If you want to get a bit more connected and are more interested, then you may even consider to connect to our network as an infrastructure AS, assuming that you would intend to run a Scion AS on a 24/7 basis and are equipped with a public IP address and also have firewall properties that would allow Scion Lab traffic to go through. We can provide you with a PC Engine device that is fully pre-configured and equipped with Scion if you're interested. So please just contact us and let us know if you would like to do so. So that's it from my side. Thank you very much for your attention, and also thanks to the Scion team, mainly Adrian Perrig at ETH, but also several other researchers worldwide. Thanks very much.
Thank you very much, David, and thanks to Adrian as well, who put us in contact with you for today. So we really appreciate that. So excellent presentation. Is there any questions? Ruben, can you see any hands raised? Because I can't seem to
no, there are none.
Okay.
Yeah, I have a quick question. And thanks, David, for excellent presentation. So in your design goals, you didn't mention security privacy per se. So although I know you have slides talking about that, was there a specific decision to not include as basic foundational design goals?
Right. Yeah, due to the shortage of time, I have skipped most of the motivation for Scion itself. So Scion actually, one of the main motivation is to overcome, the security limitations, for example, of the BGP network that, as we all know, has several limitations that can be attacked, and so that of course is one of the big motivation for design infrastructure. In terms of privacy, also, if you have the opportunity to select your own path, you can better, hide your traffic or kind of make it more difficult for an attacker to breach the confidentiality of your traffic. So these are just some of the benefits that a path-aware network provides.
Is there any specific challenge that you have faced balancing the transparency aspect versus, security privacy side?
Yeah, I mean, there were a lot of challenges actually. So this is work that has actually been performed mainly at Adrian Perrick's group for the last decade. So I think he started off with this at when he was still at CMU, and this underwent several changes until it finally came to the stage where it is today. So apparently, yeah, lots of challenges needed to be tackled to come that far.
Thanks.
So thank you again, David. And
yeah, thank you, James.
Okay.
It was a pleasure to be here.
Okay.
Sorry, I will need to drop off now.
Okay, thanks so much.
Okay, bye guys.
Okay. Bye-bye. Okay, so I think we'll hold off on the video again because we're just running a little bit short on time. We might have more time at the end to watch Mirko's video, but I just don't want to take any more time away from the next topic. So the next topic is on strengthening the trustworthiness and resilience of the internet. And just on the high level, it will focus on experimentation of the NGI call topics related to increasing trustworthiness and resilience of the internet. And we're very happy today to have Oscar Deventer from TNO from the Sflab project, who will present the open call topic in more detail and give us some details about their open call projects. Okay, Oscar, if you want to take over the screen.
Yes, Jim, thank you for this opportunity, and the invitation was quite timely because with the Sflab project, about which I will be telling a bit more, we are getting to a technology maturity level where cross-Atlantic experimentation would be very useful. So let me first introduce myself. I'm Dr. Oscar van Deventer from TNO Netherlands. I'm the scientific coordinator of the NGI Sflab program, and Sflab is a cascade funding project where we have a lot of sub-grantees that are building all types of stuff related to self-sovereign identity. Let me first tell you a bit about the motivation, and it starts with this picture. Don't we all hate bureaucracy? And several of the Americans among us may recognize the red stapler and what it symbolizes. But what we notice is that in America, Europe, and elsewhere, businesses and governments have become administration factories where enormous amounts of time and money, person decades, person centuries are spent on checking and double checking information, getting information, sharing information, etc. And then all the digital interactions are disempowering citizens because they are going to be much too complex. And also in Europe, we have the GDPR, the regulation on privacy, and personal data is more becoming a liability than an asset. So enter the NGI Lab program, the European Self-Sovereign Identity Framework Laboratory, quite a mouthful. So self-sovereign identity is about digital credentials, which have an issuer, a holder, and a verifier. For instance, a diploma, it has an issuer, which may be the university, a holder, which may be the graduate, and the verifier, which may be a prospect employer who needs to make a hiring decision. And of course, with fake diplomas, fake identifications around, all kinds of things can go wrong. And this is the type of thing that we are trying to achieve here, to achieve higher assurances, so less risks of things going wrong, less time and cost spent on compliance, better protection of the citizen. Actually, digital solutions, if you implement them correctly, they are better than paper also in terms of privacy, for instance, using mutual authentication and stuff like zero knowledge proofs for minimal data sharing. And obviously, self-sovereign identity is a source of new jobs, new business in Europe. For instance, SSI integrators, assurance communities, SSI as a service. And many of the Sflab subgrantees are already demonstrating that there is such business. Anyway, if you want to learn more about SSI, I recommend that you Google for SSI, good, bad, and ugly, and then you will find a blog about this technology and what it offers. So let me, before we go to the open call of NGIatlantic, let's first look a bit in more detail how NGI Lab works. At this moment, we have over 30 subgrantee projects. It will grow to over 50. And what we are doing is we are focusing on interoperability and joint market development. And I will give an example of that very quickly. So interoperability means solutions that work together, that connect together, where you can have one part from one vendor, one other part from another vendor, where citizens have choice, where businesses have choice, and where you have a free and open market. So this we are doing in 3 types of open calls. We have the infrastructure open calls, which is about open source components development. So pieces of SSI, for instance, the SSI wallets, where you can keep your credentials, and the SSI agents that help you securely share information that you want to share while keeping the other secret. So that's the infrastructure open call. The business-oriented open call number 1 is about generic SSI products and services. So these are, for instance, technology providers and SSI as a service providers. And then in the second business-oriented call, we have, sorry, need to circling. In the second business-oriented call, we are looking at sector-specific applications, for instance, e-health, e-government, or e-education, or maybe other topics. And we have some open calls there. They close on the 7th of July. So this is a short advertisement for those. But anyway, what we are doing, you see the complicated picture on the top right. We are together developing this architecture where the SSI components are getting together, where different subgrantees develop different parts. So how does this relate to NGIatlantic and to the connection experimentation between the US and Europe? So my this slide, my next slide is giving you an example of the interoperability work that has been executed within Sflab. In this particular experiment, 3 Sflab subgrantees were participating, Sigma, SIGPA, Fraunhofer, and Validated ID. So Fraunhofer, in this experiment, they developed a trust infrastructure solution which provides assurances for instance, the diplomas. So how to manage, how to add or remove universities from a trust list, that type of things. Validated ID made an integration with the European EIDAS framework. So the SSI standard is being developed by W3C, Decentralized Identity Foundation, the Trust over IP Foundation. By themselves, they do not yet, so they validated ID, built a bridge for that, and then SIGPA performed the overall integration. So in their experiment, they demonstrated that you have a health insurance provider. We have a citizen that wants to have health insurance, has health insurance, and the citizen can prove this to the healthcare provider using all the components from these parties. At this moment, this is within an experiment within Europe with Spanish and German parties. But I can imagine that we are doing some experiments like this also across the Atlantic. For instance, EIDAS identification is highly relevant in Europe. However, the USA doesn't have EIDAS identification. In the US, you have other identification means. Of course, the proprietary ones from the credit card companies, but many, perhaps many others. So perhaps there could be an experiment where we are connecting this to the US and include American ways of identification. So this is one example I just wanted to give you for illustration, but many more examples can be found. And actually this picture, it is the architecture of provided by the Trust over IP Foundation. It shows that sovereign identity is actually a multi-layered beast with a public utility layer, a communication exchange layer where we have the holder, verifier, and issuers, and the application layer where we have the business logic of e-health, e-government, etc. So on the right-hand side, I'm just mentioning, so when we're talking about experimentation between Europe and the US, these experimentations could be on any of these layers. So on the lower levels, there could be multiple ledgers, blockchains where decentralized identifiers are registered. And the experiment is how to have these ledgers work together using different authentication methods, etc. At the second layer, where we are talking about the secure private communication layer, often called the DITCOM layer, we could do experimentations with different types of wallets and check whether they are interoperable and how well they are compliant to trusted communication standards. And one of those is the ARIES interop profile number 1.0, of which already several parties are testing them between Europe, Canada, and America. But of course, this is only interop profile number 1. More interop work is needed and experiments can be done. And at the top layer, we are talking about interoperability in terms of legislation differences. As I mentioned already, America does not have EIDAS, does not have GDPR, but they have other things that are related. How do we make them work together? How can we achieve cross-border assurances? And also, how can we address the problem that assurance is not transitive, which means that if A trusts B and B trusts C, it doesn't necessarily mean that A trusts a diploma from C, etc. So I'm going to look in a bit more detail in layer 3 because of the time limitations, and I leave it to your fantasy to think about interop experiments, cross-border experiments on the other layers. So on layer 3, we have the issuer, the holder, the verifier. For instance, the university, the graduate, and the employer, where the graduate wants to show that he or she has a real diploma from a real university with real grades, etc. So when we are just looking at the combinatorics, we have binary options for each of them. So the issuer could be US or EU. The holder could be US or EU, and the verifier could be US or EU. So if you remove all the non-transatlantic cases, then we are left with 6 different cases. And the case that I mentioned here about the diplomas within Europe, we are developing the EPSI diplomas use case based on EPSI ESIF, which is the European Self-Sovereign Identity Framework. So one of the things, of course, is to look into pain. And why do I want to look into pain? Well, it's to understand why we're doing things. So let me take an example that is ridiculous. That is, in Europe we have railways, and in America we have railways. And let's try to do some experiments to run European trains on the American network. And the reason why I'm saying this is a ridiculous experiment, because we don't have any railways that cross the American-European border. There's a big ocean in between. So in this particular case, even though the standards for railways, for instance, platform height or gauge or other things, that they are different between America and the US, it's not a problem. So let's get back to our case of the diplomas. Suppose we have everything working perfectly in the US. We have diplomas, verifiable credentials, we have assurance, we have all the governance arranged locally, we have local wallets, local automation, etc. And same for Europe. But there is no interoperability whatsoever. What is then the pain that happens? And then we have the 6 use cases and we can analyze them. And the purpose of the pain analysis, of course, what is the problem that we are addressing? So I made a first attempt of such a pain analysis. That is a US graduate with his US diploma wants to come and work in Europe and present his diploma to a European employer. So the interop issues that we're talking about is that the university has no means to issue a US diploma that is acceptable to European employer because they are not interoperable. Or the US graduate cannot convert the diploma to something that is acceptable, or the EU employer has no means to request, read, or validate digital US diplomas. And of course, we know what then happens. We fall back to the paper version. So the US university issues a paper diploma. The graduate makes a photocopy, sends it to the EU employer who has to verify it. First of all, this results in higher cost all the times and fuss to get the paper version, get the copy, make the copy, send the copy, verify the copy, validate the copy, etc. And in many cases, the bother is not fully taken, which results in higher risk that we have a fake graduate, fake diploma, fake university. I've been told that there exist fake universities. Reputation risks for the employer, higher risk for the rejection risk for the graduate. So here we have a case that would be worthwhile demonstrating and experimenting with between Europe and America. So this is just one example where I've worked it out in a bit of detail. But of course, we are talking about an open call, and we are talking about creativity from subgrantees, from applicants. And I see that we have several tens of participants. So hopefully you can come up with other suggestions, what interop use cases that you want to address. And also, what are the pains if we use the do nothing scenario? What's the fallback and what's the societal pain there? And of course, suppose your experimentation gets to a next stage, it gets implemented, how would it be addressing these pains? So this concludes my presentation and my vision on the trustworthiness of internet. And so this part of Open Call for for NGIatlantic.
Okay, thank you very much, Oscar.
Thank you. And Jim, I think it's time for questions now.
Yes. Yes, do we have questions for Oscar? And just by the way, Oscar, when we were writing the text for our open call, we obviously involved US people, including the NSF people. So we did sort of tweak the topic descriptions to not just focus on GDPR and EIDAS, to look also at the US side. So you'll notice that on the open call. But is there anyone else with questions? Okay, well, I'm sure, Oscar, we can work together and try to, identify some partners on the US side, that are working on these pain points.
Well, actually, several of the sub-grantees of Sflab, they are closely collaborating with American partners of several types. And actually, several American companies well known for their work on self-sovereign identity have already established footholds in Europe. So
okay.
In both directions, we have collaborations. And especially relevant in the US is the Silicon Valley Innovation Program led by Anil John, which is the sort of equivalent of Sflab. So I guess that also together with Anil John, Jim, we should check which would be good American parties that he knows. Of course, through Sflab sub-grantees, we already have various collaborations, but it would be good to check that with them.
Okay, very good. Okay, thank you very much, Oscar, again, and we look forward to further collaboration. Okay.
Thank you.
All right. Thanks. Okay, with that, we'll then we'll move on to our next topic. Which is service and data portability. And the topic will focus on the challenge of personal data portability on the internet as foreseen under the GDPR and the data porting and service provider switching as foreseen in the proposed free flow of non-personal data regulation. And we're very happy today to have Najma Musin as head. I'm sorry for my
no problem. Just you can call me Najma.
Najma, okay, from Fraunhofer from the DAPSI project, who will present the open call topic in a bit more detail, and then that will be followed by a presentation by Savant Schubert and Edward. I don't have your last name, Edward, I'm sorry, and from the IDIS project, which is funded by DAPSI. So if you want to take over the screen, Najma.
So I guess you can see my screen now? Okay, great. So hello, everyone. I'm happy that I'm here, that I can present to you the service and data portability challenges that we had a survey about in Fraunhofer for the DAPSI project. So basically in DAPSI, one of the tasks of Fraunhofer was to kind of define and refine the challenges for data and service portability for the different calls. And until now, we have done it 2 times. And for the next one, we also will again refine these sub-challenges. Yeah, I have to here click it. So for this round of call in DAPSI, sorry, I have to here minimize it. Sorry. for now, we have identified 3 challenges in this round. The first one is service portability, which tries to empower users like end users like you and me to share our data with any service provider and host that we trust. The second challenge is data interoperability and compatibility, which aims to facilitate switches between different service providers. And the third main challenge is security and privacy, which aims to ensure that the personal data are transferred in a secure way. And we also kind of opened a fourth category and subdomain for those projects and ideas that may not fit into these 3 main challenges. For example, idea about data correction, data ownership, user education, especially in the context of GDPR, and etc. So, like more detail into service portability, the challenge that we identified in this DAPC project was like that we aim to make the data and identities usable and portable across services, and we want to give users the control, and so basically the users should regain the control. And for example, if you want to move from one service to another, like this import export option, it should be way easier than it is right now. And this is actually a big challenge currently. So in order to kind of come up with solution, the teams that participated in the DAPC project, they had to introduce suitable microscale alternatives and interoperable standards that can be universally deployed. And in order to do that, they could offer solutions or to create or enhance the viable open alternatives for the very key priority services that all of us depend on, as you know, Google, Microsoft, Zoom, Facebook. But because this is a very challenging task, we here in the DAPC project, we gave this option to the teams that because of the limited time, they can prepare a first version, a first prototype, kind of mature prototype that people in the community can in future can work on that and can improve their solution. So very important in this sub-challenge is that the solutions and the implementations should be open source. For the second challenge, it was data interoperability and compatibility. Well, when the data is ported from the environment, one environment from the other environment, it is very difficult because these two environments usually they have different data models and architecture, and it is that's why it's very difficult to transfer the data. But the solution here is using common standards and shared vocabularies, and also adhering to the FAIR principles, findable, accessible, interoperable, and reusable data, if I'm not mistaken. So there are challenges during this data transfer. Well, first of all, designing a cross-domain data architecture is quite very challenging, and but using established and open data model and a standard, for example, W3C standard and data models, it is quite a very good solution to begin with this problem. And another challenge is developing tools or reusing tools for data conversion from one format to another. For example, the environment one may deliver the data in XML, and the environment 2 it only works with RGF, or like something like these cases, or in a very worst case, when you claim your data from a service provider, they just give you a PDF or raw text, which is not GDPR compliant. According to the GDPR, they have to provide a machine readable data when you claim it. And the third challenge is security and privacy. It is very important that during the data transfer, there are secure data encryption and transmission algorithm implemented. And it should be a full anonymization algorithm kind of installed during this data transfer. And also the solution, they have to ensure the correctness and integrity of data after the transfer. And as I said, we also opened another kind of very broad category for the solutions and for the implementation and ideas that may not fit in these three main category. For example, ethical and legal issues for when someone transferred the data from one environment to another one, user education, for example, in the context of GDPR, data correction, data ownership, data sovereignty, and also in the very maybe interesting idea would be marketing of data portability solution, and also other topics that the teams came up in when they were applying for the APSI program. That was my presentation. I hope it was not more than 5 minutes. So yeah, if you have any question, I would be happy to answer.
Thank you, Najma. Do we
You're
have any
welcome.
questions for Najma? Okay, it was very, very clear.
You're welcome. Okay, then I will stop sharing.
Okay. All right. So if I could ask Svante.
Yes, Svante, it's a Swedish name. I'm sorry to. It's not easy today for you, especially so much for data and probability. Okay. So wait a minute, we start. Okay. So first of all, let me don't look too much on this picture right now. It should start later. So I heard a lot of these talks, and unfortunately Scott left already about the Extensible Internet and standards. He just wanted to avoid standard to use open source. So I would come now with a plaidoyer I would talk for standards. I'm an editor of a European standard for electronic invoice. So the European Commission is very fond of getting rid of paper and of digitalization. So one of the keystones in this program is to start with the electronic invoice, to get rid of the paper that's sent around, which slows down e-commerce. So, and as an editor, there's one problem, and I'm showing you here this picture. So we have to deal with two different structured data. So there's we need to give around structured data instead of paper or text. So because the main reason or the main purpose of digitalization is to, by automation, continue to work with the data without human interaction. Okay, so that is the main reason that we have structured data. But due to historical reasons, we have two XML different formats in Europe, and both are part of the standard. So that brings us to a problem, but as well it gives us, and I would like to give you, this is a pattern or a tool that you might give for your own solution, for your own problems. And the thing is, you always abstract to a higher human-centric layer. It's on the left side, where you say, okay, we have here now this treeish graph, where we say this is our knowledge graph, and we have this buyer and the seller, and then we look, where can we find this in these XML things, okay? That's what they did, the editors. This is the main thing of the specification, explaining where they can find these things for the in this XML format. And again, this specification is the blueprint, we heard it earlier about interoperability for software that people can buy or use to send around these invoices that are interoperable across the European member states, okay? And so the thing what we are doing in DAPSI here is to provide tooling, because the idea came when I was an editor and I had real pain. So how they do it? How do they provide the software developers a standard with this information? And this is pretty. Take a look here. Here we go. They have a table. They have a table of 400 pages of PDF, which is as well not very interoperable. And that's where Scott comes in, and I agree that standards currently these days are as well not very digitalized. They are very unstable, unflexible, and mostly they are not being taken into account when developing software because the blueprint is not very movable. So the key thing is to make this accessible for software, to generate software from it. And so what you see here, sorry that I don't have a presentation here, so we have to rely on some GitHub pages here. So this is a project that extracts from the standard, from an Office file, the data from the table into a structured data see below in this XML. So the same thing you can see here, which is more human readable, is here for machine readable. Like there's a semantic and that is mapped to this XML. I don't go into detail, but if Scott would be here and I'm going to write him, I'm telling him, well, instead of only doing open source, we should have a blueprint and generate open source, the main parts from it. This is more flexible because then we can have different kinds of open source, C#, Rust, C++, whatever you like, but we all have the main things in common. Okay, I hurry up. So, and what I'm doing here is now, our project, Edward Zimmerman's and mine and Tom's, is to provide in dubs, here's the Hall of Fame, is just a tooling that, I don't go into detail, I skip the, it's a tooling that gives a better validation in an editor. We use the Visual Studio Code editor to see if this is correct from the XML grammar. And we should also take a look at the semantic and align these things together. So in the end, you will just be able to put these things together because there's so many forks in the world, but there's so little merges, right? Once you fork, it's very hard to come together. And we try to bridge this gap again. All right. So that is basically the main thing. I think I should keep it short. Any questions for this? Stop presenting. Edward, would you like to say anything else? Continue on that?
You can say one of the things that's clear is
louder, please.
Well, I don't know why it's not loud, but I think one of the points also is that this is the one particular use case, but there are lots of other use cases. There are a lot of these attributes, and the semantics are sometimes not really clear and well defined, and there's a kind of vagueness in the semantics, and part of this tool is actually to hammer.
I'm sorry to interrupt you, Edward. Can you please speak like closer to the microphone, or because it's very low?
I have no idea why the microphone. Can you hear me now?
Very low, like.
Very low. It seems like you used the wrong microphone. There's a second microphone somehow.
Yeah, not better.
Not really at the moment, but maybe do you have headphones or?
Yeah, let me go to headphones. Sorry.
Sorry, I just said it's very, very low.
Okay, let's go to headphones.
While doing your headphones, so yeah, go ahead. You're ready.
Are the headphones working?
Much better. Much better.
Oh, okay. I have no idea what was heard, but the whole point is you know what he was pointing out in terms of these like invoices. That's just a particular use case that is quite dear to Svante because that's a use case that he's involved in. But there are lots of other use cases, and even within that invoicing, you have a number of like national standards for taxation, which are not quite terribly homogenized. And so you have things like date. Well, when is the date? It has to do with the tax, and when is the thing? And you need a kind of tooling to actually make this clear in sort of the documentation, so that you have this sort of knowledge from the domain experts that they can include within this. Yeah. So you have a much more complete also documentation of the standard where it becomes actually clearer what the things mean, so that in the end, when you, for example, are doing other kinds of work in sort of a pipeline and importing some data, data sets, some data records, you can also understand, wait, the date that I took here was like the date that something was published, when in fact, this is the date after something was delivered for various taxation reasons, which may be in the next year. So I have to actually understand within my pipeline, which can make quite a different thing in terms of my my balance sheets or whatever it is. Just as a simple example.
Thank you, Edward.
Okay.
Do we have any more questions? At what stage is your project, Svante and Edward?
We are on the beginning of the minimum viable product. We just not started, but we are in September. There will be something usable, right? And my aim is because MVP, right? My aim is because I'm an editor and there's work to be done at the CEN level. I would like to improve the European standard by making this open source and directly usable and get feedback from the editors. But there are more standards and and more problems similar to, and it's missing tooling. Yes. So I like to connect with people like Scott, like, hey, do you need this? Do you need this? Is this kind helpful for yourself? Like, would you like to extend it yourself? Yeah. So I'm getting in contact with you.
Okay. Well, the timing is very good because, as I said before, our project is looking to, take the results, when they're available, and then you can team up to run experiments with the US people. So I think the timing would be spot on from that perspective.
Yeah.
So that's great. Okay. Well, thank you very much.
Thank you for listening. Thank you for the opportunity.
Yeah. Okay. Thanks so much. Okay. I know that there's a number of other TAPSI participants in the call, but I'm not sure if they want to say anything else at this point. So if you do, you can raise your hand or put something in the chat. Okay, so let me share my screen. Okay, so we move on now to the next. I can hear myself again. Can everyone mute their microphones? Okay, that's perfect. Okay, so our next topic is greening the internet, a sustainable and climate-friendly NGI. So just as a bit of background for this, it currently wasn't one of the named topics in the NGI initiative per se, but it was a topic that has been identified by the NGI Forward project, which is a coordination support action project in our family of projects, which is looking at the strategy and the program building of NGI. So they've identified a sustainable and climate-friendly internet as one of the key NGI topics in going forward, and they've done work in this area. And on the top right of the screen, I'm highlighting a report that they have published called the Internet of Waste, and then they also have another report called Breaking the 2-Year Cycle. So sort of with this background, and then our own project has an external advisory group, and we had a meeting last November with the advisory group, and which includes many of the NGI coordinators as well. And one of the topics that kept coming up again and again was the greening of the internet. So we decided to include this as a topic in our Open Call 3 and now again in Open Call 4. So in terms of what the focus is, it's on again, experimenting with results related to use case implementations of innovative internet technologies and transparency mechanisms on EU-US experimental platforms shown to fight against climate change with significant improvement of energy efficiency, carrying out some measurements to create awareness of environmental impact of the internet and promotion of technologies that help reduce the energy consumption and carbon emission. And so in essence, we're welcoming applicants that can provide an experiment with transparency mechanisms and sustainability metrics on the environmental cost of the internet. So when we were discussing these topics with the NSF, this is also something important from the US side, of course. and where you have very, very large platforms being funded, which you heard about earlier from Deep, and so of course they're conscious of the sustainability aspects of this. So they'd be very interested to see some experts from Europe coming together with experts from the US or vice versa in looking at this the environmental aspects of the internet. Okay, so I just invite you to check these sources of information from NGI Forward, and the coordinator of NGI Forward sent her apologies. She couldn't attend, but she just wanted me to present those for her. Now we have a speaker, Dr. Zatlo Zaharev from Morris Limited, and he's going to present the Rouster PC, the next generation PC. So, Zlatko, you want to?
Hello. Yep. Hi, everybody. Let me just share the screen, and I hope it is visible now. So hi everybody, I'm Zlatko from Rouster. The legal name of the company is Morris, but the project and the product itself is called Rouster. And we're alumni of the NGI Export programs. I spent personally 3 months in the US working together with Stevens Institute of Technology and with Professor Muli and his team in order to prepare the next step for Rouster. And of course, now we're keen to continue to the next step of Rouster, of course. But what is Rouster about? So Rouster is supposed to bring you out of a vicious circle that we all live in, and it is a simple one. It starts with buying a computer. We pay a lot of money for it, but at this moment we already know that it will be slow and broken and not working in just several years. And in any way, it is fun because it is a new computer, except that it's not really fun because now you need to install your software to synchronize your data, to move licenses from one computer to another computer, and so on. And only then it becomes fun, but not for too long, because as you work, you start to install more software, you generate more data, your computer becomes slower and slower, up to a point of regret when you have a computer, but it's actually not working. And then you throw it away, generating frustration, and more importantly, you generate a lot of electronic waste, and then you restart the whole process again. And the reason that this is happening is because the most fast aging components in our computer are actually also the most expensive one, and they consume the most power of it. And to mitigate this, we actually remove all those hardware components from your computers. We move them into a cloud, and now we have a computer which can work good for you indefinitely in time, so you can just stay in the fun part of owning computers for forever. So it is pretty simple solution. And going for the greening part of it, there is some researches that shows that an average person actually goes through dozens of computers in his or her lifetime. Most of the time with several computers simultaneously, and this is generating a lot of electronic waste. Those computers, with the time, they're consuming more and more electricity, and when we're going through the circle, we are actually generating a lot of electronic waste. And Rouster is supposed to be really, really practical new look of the personal computer. It is just the same computer. There is no difference from user's perspective in using Rouster or a conventional computer. But you will not ever need to upgrade it anymore. You can use this computer forever. it is supposed to be your only computer, of course, if you want to be only your only computer, because currently you need a lot of devices just to actually do the same job, but on different form factor. Like you need a tablet when you're on the go, and you need a desktop computer if you need something more powerful, and the laptops are somewhere in the middle. With Raster, you can use only one computer, your only computer on any devices in any form factor, but without the significant hardware in them. Those devices, because you don't have the hardware, they're just really cheaper than conventional computers. And apart from this, of course, Raster computers are more secure, and you have some customer service in it. So when you have a problem, you know who you can call with it. But according to our initial calculations, putting those hardware in the cloud and using it, and using just the small devices and monitors to use them, you can actually lower the amount of electronic waste and electronic consumption by between 2 and 6 times. But talking about the product itself and the market that it should go, because Raster is supposed to be really practical product from a business perspective, and in order for it to work in a long term and to be able to be accessible to more and more people, it should also be working in a good market and be developed as a sustainable business tool. Raster is actually entering the personal computer market, which is really huge market, and it is worldwide. It is really scalable opportunity. And while with the rise of the mobile devices, a lot of people start thinking that probably the personal computers are going to shrink the market. The market of personal computers is going to be shrinked. It is actually not shrinked, and it is actually rising. It is a bit flat, but it is still rising. So what we're doing, we're combining 3 different technologies from 3 different markets. This is the so-called desktop as a service market, think clients or zero clients market, and we bring technologies from the gaming industry or so-called the cloud gaming to create the user experience just exactly the same as a conventional computer. And of course, there are some other companies working in this area, but apart from them, Raster is fully working computer that can be used for any workflows, not just for some of them or for a specific workflow. Raster is general purpose computer that actually works in any workflow, and it can generate profit which cannot be said from a lot of other companies there. So this is, believe it or not, but this is actually a unique thing about Raster currently. So what happened up to now? We already prepared 2 proof of concept products. One of them was European-based over Austria, Germany, Switzerland, and Bulgaria. And the other one was with the help of the NGI Explorers programs over the US. For both products, we validated the technology, and this was really important. And we also validated that this technology is really feasible over the currently available network connectivities and also over 5G. Also, we were able to test this with real potential users, and we have some tremendous results. 90% of the users were ready to buy it now. And to be sure that this is actually really working, we also created a web page where we start selling the product. Not for real, because it is still not ready for the retail market. But we were tracking the users down to the funnel up to the moment when they click pay now, and then of course we were saying that we're sorry, but they need to wait a little bit more. But this costs us around 8.5 euros customer acquisition cost. So what we want to continue to do is to prepare this product fully for entering market and start to spread it across more and more users as fast as possible. And as a business model, we are a combination of cloud service subscriptions model and optional hardware devices sales. So everyone who needs a computer actually can benefit from Rouster, because our plan starts from €4 per month and the hardware starts at €60 per month. And an example of hardware is something like this, which is actually able to fully exchange your current desktop computer. It works better. It is really smaller, and it costs only €60. So this is really, I believe, really good offer, because any sustainable business needs to be a win-win situation. So it is really a good offer to our future customers, and in the same way, it can generate really profitable business for us. And basically, this is what Rouster is about. So I will be happy to answer any further questions. Thank you very much.
Thank you, Zlatko. There's one question on the chat. What would make these computers more secure?
Well, first, your data are secured in a data center, so you now received data center grade security. And second, you don't bring your data with you. So if your computer, for an example, is broken, you're not going to lose your data. And even worse, if your computer is stolen, there are no data on it. So if you think about Rouster and the data, you can think of it like you're thinking about your debit card or credit card and your money in the bank. You don't need to have money with you. So if you're robbed, you can just block your card, and it will be, and you will not lose any money. Of course, it is not always 100% secure, but it is much more secure than if you bring money with you. So the data are more secure, and also, of course, we can analyze the network activities and so on, so we can take care of it even more. On the other hand, talking about privacy, we are applying the idea that even we don't know what you have on your computer. It is fully encrypted, and we cannot access it unless you give us the permissions for this. I hope this answers the question.
Okay, thank you. Is there any other questions for Zlatko? Okay, all right, thank you very much, Zlatko.
Thank you. Now, yeah, thank you very much.
Okay. Okay, so our next session is on the fifth NGI topic, which is internet data sharing and interoperable services. And this topic actually is not precisely one of the ones from the NGI initiative, but it's a very important topic, and it was one that was suggested by the NSF. And you know, of course, there's a lot of good work in this area in the EU as well. So just as a high level, the topic will address the challenge of sharing network data siloed in different internet regions across geographic boundaries and enabling trusted internet services like composition and orchestration of globally distributed services. So it's addressing things like secure and privacy preserving data sharing, which is particularly important to address the rising cyber threats and incidents, which are global in nature and multi-layered. Sharing of internet data to support the continuous monitoring and data-driven analysis is critical to identify the impending or ongoing attacks, support traceback and attributions, and intelligently respond to internet events. So we're looking for experiments related to such cross-domain data sharing challenges to enable cyber threat identification, risk assessment, and incident management, and enabling secure and interoperable internet services in our open call. And just as a point of note, in contrast with the service and data portability topic, which we heard about earlier, this relates more to the role of data sharing for the purposes of cybersecurity rather than for services and applications. So for this topic, I would like to invite Dr. James Jousey, the Program Director from the Secure and Trustworthy Cyberspace Program at the National Science Foundation. And then James will be followed by Dr. Ahmad Arslan from the Cardiff Metropolitan University. So James, would you like to give
Thank you, Tim. Yeah, I would like to share the screen.
Sure. Let me stop.
Okay. Can you give a sense of how long we have? I don't want to take too much time. I have a few slides I wanted to share.
Yeah, I think we're a bit ahead of schedule, so you're okay if you want 15 minutes. It's no problem.
Yeah, I won't need that much, but let me.
That's fine.
Thank you, James. And I'm James as well, James Jousey from NSF. I'm a program director of Secure and Trustworthy Cyberspace Program. So within this context, I wanted to just quickly touch on some of the programs that we have, and that touches on different aspects of different topics that's covered here, in particular, this data sharing and interoperability aspects. So I'm part of the Secure and Trustworthy Cyberspace Program, which is probably one of the biggest programs in NSF, highly multidisciplinary, where we have participation from Computer and Information Science and Engineering Directorate, Social, Behavioral and Economic Sciences, Education and Human Resources, Engineering, Maths and Physical Sciences, and so on. And we have about $80 million of budget annually. At any time, we typically have 900 plus active projects. And as shown by multiple directorates participating in this program, it demonstrates our recognition that this is highly multidisciplinary field, the cybersecurity and privacy aspects. And so in a way, SATC, as we call it, is a flagship research program for fostering foundational, highly interdisciplinary research in security and privacy areas. And we fund projects at different levels in different categories. Core category focuses on foundational research, and it could be small, up to 500K, medium, up to 1.2 million, and large or frontiers. Frontiers are $10 million projects that are very transformational, very bold in nature. And so one of the recent ones is actually focused on protecting personal data flow on the internet. So it covers security, privacy, with significant focus on privacy aspect, but looking at it in multiple, from multiple perspectives. And these are different topics that we cover in SATC that includes significant focus on networking issues, wired, wireless, and privacy aspects, intrusion detection, and so forth. So this is just some listing that we provide to potential principal investigators to give some guidance. This is not an exhaustive list. And there are several other programs within NSF, in particular the Computer and Information Science and Engineering Directorates that touches on topics like internet data sharing and interoperable services, infrastructures, and so on. So I thought I'll briefly mention these, especially for our European colleagues. So I'm part of Computer and Network Systems Division, which is part of SISE, and it is the division that also manages secure and trustworthy cyberspace program. We also have networking technology and systems program looking at specific network related challenges that include some security privacy aspects. We have Office of Advanced Cyber Infrastructure Division that funds many infrastructure building projects. that includes cybersecurity infrastructure and other types of infrastructures. Currently, there is a significant focus on national AI research institutes. These are multi-million-dollar centers that we have started funding. And in the current cycle, actually, it's focused on, we are soliciting proposals that are focused on AI and advanced cyber infrastructure. So this could be related to any cyber infrastructure, including network, internet infrastructure, and so on. And also advances in AI and computer and network systems. And that's broadly very foundational, focus on how to use AI, or what is the intersection between AI and the future research directions in computer and network systems. We recently had this program called Resilient and Intelligent Next G Systems, very broad, looking at as we go beyond 5G and other integrated system infrastructures, cloud, edge computing, and so forth. How do we look at building highly resilient and AI-based infrastructures that we constitute as the next generation systems? And that would need a lot of data sharing across different borders to ensure the resiliency and security privacy issues are properly addressed. We have other programs like smart and connected communities with social well-being as the goal, but that includes connected communities at different scales and levels. We also have SIZE Community Research Infrastructure Program that supports general research infrastructure building proposals. There's also industry university cooperative research centers that we fund, where we basically support academic researchers to partner with industries to foster research activities that are relevant to academics as well as industry. This is another example of high priority areas, harnessing the data revolution. That's what we are seeing. A lot of data is available, and it's touching on foundational systems aspect, data intensive science and engineering issues, education and workforce, touches on almost every aspect of our life, as you can see in these ovals. Real-time engineering and systems, for instance, would really need efficient data sharing, for example, related to internet data and so forth, to ensure we harness that data-driven social good. So these are different programs and priorities that we have at the NSF. And these are different infrastructure programs that exist at different levels of funding, from few millions to multi-million dollars. And here I will pass it on to Deep to maybe cover this a little in depth.
Yeah, thank you, James. If you could go back to the previous slide, I wanted to add something to it. You have some information. I wanted to add or emphasize rather that with the amount of data we are going to face from DNA data, which can take for per person with with the metadata and everything per person, like 25 gig from what I hear, and imagine multiplying that by thousands to millions of people, potentially, assuming at some point people are willing to share it for analysis purpose. We have a very interesting data sharing issue that comes up, and how the compute might play in the middle of it. And secondly, when you do sharing of data, it is possible that something like a DNA data, that somebody may say, no, I want to share it only for studies related to diabetes, but not related to heart disease. So you have another level of information filtering that will happen at that level. And secondly, somebody might even say that on my DNA, I want only to look at chromosome number 9, not any of it. So what brings it is that from a privacy and a security perspective that James handles in our program, that we need to think about all of these things related to differential privacy and data sharing, for very important and context coming in. And then when you have a networked way of connecting the data to analyze the data and where it is going to be, we believe that something like when a Fabric platform, for example, within network compute and storage, and sort of creates a very distributed way of looking at with data sharing and the privacy and rather differential privacy is going to be extremely important research problem to kind of look and for our investigators to look into. And I hope there are interest in from the European researchers to look into that. James, can you now move into the next slide? And so yeah, I wanted to give you our Directorate's perspective on different infrastructure without going into a lot of details. On x-axis, we divide it into two categories: individual and institutional infrastructure, and or the community. It is for the community. And on the y-axis is based on the size. So if you have award size, that means $1 million to $20 million rates. If you were here earlier in the morning, I briefly mentioned about IRNC, International Research and Network Education Connection, and that expands, for example, programs like Fabric to connect to the Europe. That's all. You can see it is in the $5 million sort of a range, and it's a community infrastructure. I talked about Future Cloud with Cloud 11 Chameleon, and those falls under there. When the Cloud Access is our public cloud program, and actually Fabric falls under the mid-scale 1 program there. And then we also have smaller programs, campus cyber infrastructure. That's what CC star stands for. And that actually are the smaller pieces that can connect to bigger pieces to something like the Fabric and our Internet 2 to connect to for research purpose. And so I wanted to kind of give you that with all of this thing, how it addresses different scale-up problems that we need to address. Secondly, all of this has a different aspects about data sharing that kind of comes into the picture. And the reason I wanted to bring this up again, that with the COVID that happened, started in last year, we faced with that how is the internet working sort of a situation. So I funded what we call the NSF call it Rapids program, up to $200,000 to look at the internet health last year. So with that, the issues related to, again, data sharing, how we can measure it, that aspect that come in. And in fact, James and I and a couple of our colleagues are now looking into that if we sort of do a internet measurement type way of looking at a new program, that is going to require us to have a data sharing with privacy concerns and differential privacy, multi-party computation, curated data, de-identified data to be shared, and so the research can use it for their interests. And we know that not all data might be publicly shareable. That's why we have to live with that. Then a researcher but at the same time, we want reproducibility and repeatability of research to be possible. And so if you sign we make the data available to some site, you sign an NDA, you can actually do the follow-up research using the data set for your work. So those sort of things we're also thinking about, and I wanted to kind of bring it up in the context of data sharing, especially in the context of privacy and large data. So with that, I'm going to stop it here and see if anybody have any questions for James or me.
I do want to add one more, I think I missed earlier. There's significant interest in terms of data sharing broadly. And of course, internet data sharing is one aspect of that. And this was our recently held workshop where many agencies came forward to discuss about how we can share the agency held database. So it was data sets for public good. It was kind of narrowed to a specific scope of US government, but beyond this, there's a much growing interest within the federal agencies about how to do sharing of data across the border and how to foster privacy preserving technologies, machine learning, and other types of technologies to really share data for and apply techniques like machine learning and so forth for supporting social good. So there's a lot of interest, a lot of activities that's taking place. And so if you have ideas in this space, that's something we really wanted you to think about.
Okay, thank you very much, James. And is there any questions from anyone? I mean, as I mentioned, there certainly is plenty of good work going on in the European programs, both in NGI and also in other the cybersecurity, privacy, and trust areas of the Commission as well. Okay. All right, well, thank you. So next we have Dr. Ahmad Arslan from the Cardiff Metropolitan University. Who's going
Hi,
to
everyone. Hi, James.
Hi, Ahmad.
Yeah, just to be sure, can you hear me loud and clear?
Yes.
Okay, great. So let me share my screen.
Okay.
All right. I hope you can see it.
Yes.
So welcome, everyone. I'm Dr. Arslan Ahmed from Cardiff Metropolitan University. And today I'm going to discuss mainly about how we can evolve the network services management and network architecture for 5G using enabling technologies such as software-defined network function virtualization, and artificial intelligence and machine learning. So broadly speaking, in Cardiff Metropolitan University, we are conducting research on quality of experience, how a user perceives a service quality. This is mainly related to multimedia communication, and how we can integrate user perceived quality into network management and monitoring architecture. Mainly, we are focusing on multimedia communication, video streaming, next generation multimedia communication such as 360 videos, augmented reality, virtual reality. We are trying to apply data-driven approaches for network management so we can effectively allocate the resources throughout the network and how a network can incorporate a user perceived quality into the architecture and service delivery. And we are focusing toward an agile and softwareized future network architecture. So before going further, first I would like to discuss what are the current internet architecture challenges and what are their limitations. So starting the talk with a motivation, why we are doing all this research is because this industry has a bigger potential to grow. And this is a prediction that 5G infrastructure market is going to grow up to, 400 times larger in the future. And we are going to also see a prediction of higher number of connection growing per application, whether it's a wireless or whether it's a wired connection. So generally speaking, the multimedia communication is composing the major portion of future internet right now. and it is going to grow even bigger and beyond. So most of the services, for this workshop, we are using a multimedia service. So you can imagine how a multimedia service is getting evolved over time, and how the consumption of multimedia content is being delivered over the time. So there are three major questions which I would like you to ask before we go further. So the first thing is, with this growth of internet connections, how do we manage a network which is evolving in that faster pace? And how we can ensure that we are delivering a better quality? Right now, the current network we are using is mainly based on the best effort network delivery. And the third biggest question is how we can automate the network optimization. So starting with these three questions in mind, I would like to further explore what we can do for the future network and how we can work in the direction to solve these big three questions. So starting from the internet architecture, in the current internet architecture, we have three major players. First is the users, us. We are consuming the service, and those services are mainly delivered by the over-the-top providers. Just to name a few big names, YouTube, Netflix, they are providing us service over the internet, and we are connected by the internet service provider. Generally, our research for the network management is driven on the ISP side, because here what we see is a bottleneck in the service delivery, and here are a lot of opportunity to really evolve the internet architecture. So the major challenges in this part is that the current internet, we need to manually configure the devices. I think most of the audience here would have gone through a CCNA course already, and they know that before we place any network device, we need to manually configure it, and it delivers no automation and flexibility. This is the major limitation for the current internet infrastructure. And the second point is the operational cost. So for MNOs or internet service provider, in order to configure these devices manually, we need to set the teams there. And for this, the operational cost is really a lot. And another major issue and limitation is the quality requirements of the multimedia applications are different. So using a best effort internet is not enough. We need to evolve the internet, so it should include the user perceived quality or application quality into its architecture already. And we cannot keep a global view of the network so far, because we have a decentralized control, and having a decentralized control, we don't have a global picture at all. And current internet doesn't even consider a bit of user perceived quality into the network management and architecture. So these are the major limitations which I would highlight, that in 5G, we should not be having these limitations, or in 6G networks. So coming to how we can avoid these limitations, thanks to network softwareization, virtualization, we can deploy now AI and ML algorithm on top of SDN controller or NFV mono architecture in 5G and 6G networks. So we can dynamically allocate the resources and come up to overcome these major issues in the current internet. So just an overview of software-defined networking. So in the traditional network, we have the control and data plane together. While in software-defined networking, we have a control plane separated from the network devices, and we can really deploy a dynamic algorithm for resource allocation of all the network. We can keep a global picture, and we can program the network thanks to this technology. The next one in the key enablers is network function virtualization. So this technology allows us to deploy all the network functions, most of them, on the virtualized infrastructure in the data servers, in the data centers, and we can deploy the virtual router switches, which can be controlled by the softwareization empowered by SDN, and we can automate and scale our infrastructure. And the last technology which I would like to mention is deploying data-driven approaches on top of software-defined network controller and network function virtualization. Here is a use case of using AI ML-based query monitoring and management solution. So we can derive our network, we can manage our network based on the data we gather from the network devices or from the user devices. We can use that data to manage our network a little bit more effectively, and we can lower the cost, the capital and expenditure cost, capital expenditure cost and operational cost, capex and opex. So how we see future network is kind of softwareized and virtualized, and it should enable an end-to-end virtualized network. So the major effort is related to most of the core networks. They are softwareized and virtualized right now. However, the major problem is related to the access network. So the key takeaway right now for us is how we can virtualize a radio access network and how we can softwareize it. There are some efforts happening at the ORN, which are performing the standardization for softwareization and virtualization of the radio access network. But still, the technology readiness level is, I would scale it at 3 right now. So I think there are a number of opportunities for this. And in 5G and 6G, we should have application-aware network slicing. So there should be a separate network slice for each application, which can ensure the application requirement. There are a number of new applications coming, such as the health-wearing devices, our automated cars, and all. And based on those new emerging multimedia applications, we have a set of different requirements to ensure the quality of service and quality of experience to those applications. So in my opinion, there are these few challenges which we should definitely take into account in the future research, and that is an end-to-end slice for the multimedia application, where we can automate these slices, and in order to deliver the best quality to the multimedia applications and to decrease our cost. The second challenge is related to security and privacy, because if the future network is going to be data-driven, we need secure, really fast interfaces to deliver that data-driven approaches among different entities like over-the-top and internet service providers. And another key challenge is related to softwareization of RAN networks, how we can really softwareize and virtualize most of the network elements in the radio access network, how we can replace FPGAs with the accelerated hardware such as GPUs, as most of the radio protocol stack at the MAC level, the algorithms are really in the real time. So how we can really effectively use the power of softwareization and virtualization at the radio access network. Most of the applications such as automated vehicles, how we can ensure that the mobility management in 5G or 6G networks take into account to the requirement of those applications, how we can have seamless handovers for these multimedia application. And last but not the least, how OTTs and ISPs can collaborate to provide a quality of experience-based network service management and delivery of multimedia application. So thank you all. In this one, I would like to conclude that we discuss the current network architecture, their limitation, how the key enabling technologies such as AI, ML, software-defined network, and network function virtualization are transforming the network service management in 5G and 6G networks. What are the key enabling what are the key challenges in future network, and how these enabling technologies are defining the future internet architecture. So thank you so much. If you would like to contact us to collaborate, you can scan this QR code or you can contact me by email. Thanks a lot, and I'm happy to take any questions.
Thank you very much, Ahmad. It's very, very good presentation, and I can see your ideas actually covering a number of the topics, and maybe I mentioned it, but I should make it clear here that that applicants can cut across a number of topics. You don't have to just be in one. So I could see yours covering the experimental interconnections as well as the internet renovation, and even this particular topic on data sharing. So thank you for that. Is there any questions for Ahmad?
I have this is Deep Mehri. I have a question, Ahmad. Can you hear me okay?
Yes.
Yeah, my question is that you talked at one point about that every application must have a different slice.
Yeah.
And if you think from a management perspective, that's going to be extremely difficult because for a number of reasons. One is that the applications are going to be increasing and the dynamics of it. So eventually you have to do some sort of a trade-off between what you do slicing for a for an application versus other factors. And slicing as a concept is a great idea, but from a management perspective, this is the most horrendous topic actually, from what I can see. So can you comment on that a little bit?
Well, I totally agree with you, Mehdi, that it will be challenging to really manage multiple slices per application. However, I believe that if we separate the slice and we form those slices based on the QE or QS requirement of those applications, will deliver much better than having a best effort internet.
No, I mean, I don't disagree on the delivering best effort, internet. That's not the issue. Issue is the managing the slices. We know that conceptually, theoretically, you can prove that slicing is better for delivering better QoS for different application.
Really?
I'm looking at it from a management of the system perspective. So you have to at some point do a trade-off between that. So
exactly, and this is where the network service and management research need to play the role.
Okay, thank you.
Yeah. And I would classify it as a blessing in disguise. So I think, in my humble opinion, it is challenging, and this is good for us as a researcher.
Okay, thank you again, Ahmad. So
I would stop sharing screen.
Okay, so I would suggest we take just a 5-minute comfort break, and then start again. And please stay with us. The next session is on the Open Call 5 topic discussions, which will be very interesting. So I suggest we just take 5 minutes. Ruben, do you want to maybe queue up that video and see if it might play? So, during the break, if anyone wants to watch the video.
Sure.
Okay. I just need to grab a drink.
All right. Thank you.
Hello, everyone. I'm really sorry I can't be here in virtual live session. I'm at the moment in an exam period with my students, and that has unfortunately priority over projects. It's an important time for the universities to examine our students, and it just takes priority. So my apologies to Jim and everybody on this session. We have now been working for a year and a half with NGI Pointer, which is addressing open internet architecture renovation. And we've just also closed our second and final open call in the project. And now we've selected a total of 36 projects in the first and second open call. That brings us to a very exciting portfolio of different project addressing very broad term as we see it. So it's not just strictly speaking the protocols that make up the internet, layer 2 in particular and layer 3. So IP TCP, for instance, but a much wider set of activities also reaching into the application layer, actually, strictly speaking. So the web, as well as some core internet applications like email or a browser, as well as some communication protocols that could be seen as applications, as well as social media type services as well. So we still think that we have an extremely exciting portfolio. I will share a link with Jim that he can share now in the chat, hopefully in the session, where you can find the booklet, as we call it, for the first set of open call projects, and maybe there will also be some additional material made available during the session as well. So out of the different types of projects, we have a number of projects that address layer 2 and 3 clearly. So these are projects that look at multipath TCP, for instance, 5G networks. It's congestion control protocols, or contributions that are at the IETF in the transport group. We have activities that look at new ways of determining how networks are formed. We have receiver-driven income traffic management, for instance, trust and authentication projects, as well as we're working together with WireGuard, who's working on, of course, the VPN tunneling technique that is now also residing in the Linux kernel and is also made more widely available. So we're very happy to fund that too. We have also activities on security. So we're looking, for instance, at a firmware library, as well as sort of more edge computing oriented activities on security. And we have a wider sort of privacy by design communication protocol set of activities. So this is 4 projects that both work in, let's say, more social media-oriented activities like gossip protocols, Scuttlebutt, Pyrgos, which is a decentralized end-to-end encrypted and trustless protocol that is wrapped into a service that offers various functions like document repositories, as well as social media activities and messaging. As well as Carusa, which is a wireless optical communication system for urban environments. So it's actually more of a hardware project that has quite a few software components as well, of course. And we also have a number of projects that are of a much larger context, like Scuttlebutt and Pyrgos, of course, as well as Carusa. But things that have been running for quite some time. So we have, as an example, also a project on Scion. So this is specifically on verified secure routing for Scion. And Scion has been many researchers across the globe, including the US and Europe, where Adrian Perrig from ETH, for instance, is quite central in the contribution to that and keeping the community together. We're also working with the Solid suite of protocols that probably relates better to W3C, the Solid standards. And we're also working with a variety of other sort of maybe more newer types of protocols, or protocols that are maybe a little bit outside of the scope of the traditional set of protocols in the internet, such as, for instance, IPFS, or on the email side, for instance, also on JMAP, how this is sort of picked up and taken along. We also have a couple of projects, or now actually a few more projects, maybe in the newest open call on virtualization, and a few projects also on identity. So quite a good portfolio. I hope you can have a look at the link that is being now shared with you. Otherwise, you can find it on NGIpointer.eu. You can find that under architects there as well. So I hope you have a fantastic session, and I wish you all the best for the US-EU collaborations and future projects. And if you have any questions, you can of course contact me at mirko.presser@btech.au.dk. And maybe Jim can also share my details with you on this one. So again, my sincere apologies that I can't be here today, that I can't be in the session and answering your questions and contributing to it. But I hope that you understand that exams have priority right now, and my apologies again. Thank you very much.
Okay, thank you, Ruben. Came through quite well. I'll share, of course, Mirko's information if you want to get more details from him about the NGI pointer projects. Okay. So the next part of the program today, actually it's the last session before the wrap up, is we've already began some initial discussions about the Open Call 5 with the NSF, and a number of topics are already under consideration for this. As Deep mentioned earlier, in around the September-October timeframe, there's going to be 8 or more nodes coming on stream for the Fabric platform. So, the Fab project, which is the internationalization of Fabric, will really be picking up at that point, and it could be very, very worthwhile for NGIatlantic to fund the EU side for those collaborations. It would be a perfect matchup. We've also been discussing another topic that we call the human-centric and inclusive internet. So we'll be looking at how the key technologies of NGI could enable measurement methodologies for doing a more granular measurement of internet availability, bandwidth, and quality of service, particularly in remote and underserved areas. So this is, this is an area that's we would like to see some collaboration across the Atlantic on. And then, of course, we can discuss some other topics. So for this session, we're very happy to have Ms. Anita Nikolic who's the Director of Research and Technology Innovation and Research Scientist from the University of Illinois at Urbana-Champaign, USA. Thank you very much, Anita, and I'll stop sharing my screen. Oh, looks like I wasn't sharing my screen. Sorry.
Okay. Can you see that?
Yes.
Okay. I won't talk for too long, but I do want to give you a general overview. I'll make the slides available, and people can email us if they want to ask some questions. So, our project, the original project, is Fabric. That is a U.S.-centric project. Last year, the National Science Foundation gave us some funds to expand to 4 locations internationally, 3 of which are in the EU, UK area. This is just to show you the broad team, the leadership team in the US. Why Fabric? Just if you're not familiar with it, I'll give you our website. There's lots of presentations. So basically, because compute and storage is very inexpensive now, we can build a whole entire future new internet. Some of the things we're hoping people experiment with are the possibilities of machine learning and AI. This is really an experimental test bed. Something beyond, hopefully just self-driving networks. With all the IoT and 5G, especially in the EU, we're hoping people do more, to combine the kind of edge and core of the network and do some smarter workflows. What is Fabric? In a nutshell, if you're familiar with larger scale test beds like Genie, it is somewhat like these larger scale, Fed for Fire or Genie. But we would like to think of it as enabling a new paradigm for distributed applications. So the network is fully programmable, compute and storage at each node, GPUs, FPGAs, NICs, storage, all inside the network, quality of service guaranteed, many 100 gig or higher links with dedicated capacity. And Fabric and Fab will interconnect all these kinds of facilities, high performance computing, test beds, commercial cloud, internet, anything you can think of, we connect to. This is the US topology. We have 29 nodes. These are some of our drivers. Again, I won't go into too much detail. Some of the key features, what you want to keep in mind: fully programmable, scientific instrument, peer with the internet, and fine-grained measurement everywhere. This is our expansion to the EU. Our first site is going to be at CERN. So we'll be going to Japan, will be our last site. University of Bristol will be next year. University of Amsterdam, CERN. I'll tell you a little bit about these. These are the use cases that Fab has brought in. These are just initial use cases with initial partners: astronomy, weather, physics, a lot of urban smart city stuff, computer science, cybersecurity, which is the area I deal with, adversarial AI. I would love to see people attack AI models in this testbed. Again, some of our science use cases in the actual institutions. Some of you may be from these institutions. And the dates, which you probably want to know about: CERN will be up and running and sending traffic back and forth, initially at 10 gig, then at 100 gig, starting in November. It's followed by University of Bristol, Brazil, Tokyo, and University of Amsterdam that may be accelerated. I won't go into this, but just to give you a flavor that Fabric and Fab, it's a disaggregated router. The nodes have compute and storage. Measurement, we have GPS at every site for super fine-grained measurement at every site, and NICs that'll do packet sampling and time stamping. Again, optical layer. I will not go through this. External facilities, these are your facilities or your equipment. We have highly federated software. You can connect anything to Fabric and Fab, including the public cloud. Your campus, anything in your campus, your laptops, your computing, anything you'd like. We have a very robust security architecture. Our services are a combination, whatever is best for you: layer 2 point-to-point, layer 3 routed. We have some physical connections, and even throughout the EU. And finally, a whole lot of peering. Some of our near-term use cases you can see here, which I've gone over. In the future, think of your favorite really cool use case. We'll support it. We're bringing on early users. It's beta testers at the end of this year. Beginning of next year, we are going to be fully operational at all those sites I showed you by the end of 2023. But you can start early. It just, you won't have access to all those sites. Finally, we have a whole lot of stuff on our website, whatisfabric.net. You can sign up to be an early experimenter. If you need a letter of collaboration, just let us know. So thank you.
Thank you, Anita. Actually, a question just came in, and I was going to ask you the same question. Is it possible for you to share the slides or some
For sure.
of your slides? Okay.
Yeah. Do you want me to send them to you, James? I can send them right now. Cool.
Yeah, that would be great.
Sure, no problem.
Thank you. And just on the slide you had with the nodes on it, I didn't notice whether you had them color coded, in terms of which ones would be done this year as opposed to next year. Is that information available? As I understand from DEEP, I think there's supposed to be 8 of them, by Q3 2021. It just might be of interest for those that are looking to get involved as use cases, perhaps through NGIatlantic.eu, to know which ones would be the ones that are coming on stream in 2021.
So Chicago will be up. There will be Deep's right, about that many by the end of the year, covering all. There's some kind of in each area. The big ones, of course, are Chicago, LBNL, which is Berkeley Labs, and RENCI, which is down here. And in between, we will be filling in some of these. I can provide you the schedule. And by September 15th, ideally, CERN will be online and connected with traffic flowing by November. And ideally, University of Bristol will be online in February with traffic flowing to Bristol over those international links.
Okay. That's great. Does anyone have any? There's a couple of questions. Does anyone else have any questions for Anita? Okay.
I have a quick question. This is James. Thanks, Anita, for excellent presentation. You mentioned about robust security architecture and so on. I was wondering if you have support for, say, for example, privacy-preserving machine learning, secure multi-party computation, enclaves, forming enclaves, and so on. How these things can be achieved in the fabric or fab infrastructure?
So I work in the area of MPC. In terms of PPML or privacy preserving machine learning, we are highly encouraging our experimenters. So we provide the ability to do PPML. We're hoping between, say, yesterday we had a call, we're hoping between kind of IoT or sensors between cities or between locations. Fabric enables PPML because you're not taking the data back to do your inferencing in a central location. Because of our cards we have at the locations, we want people to do inferencing and do federated learning across sites. In terms of enclaves, we do not have like SGX, those kind of enclaves. But if you want to bring your own, you can use SGX or kind of TEE, those kind of enclaves. But anything else, we provide the infrastructure for. Does that answer the question?
Yeah, that does. And is it right now only within US, or is the fab also ready for?
It is only within the US. September fab will be at CERN.
Okay, thanks.
Sure.
I have another question, Anita. Obviously because of the COVID situation, travel, for our applicants to the US has been difficult. Now that might be improving in the autumn. We don't know yet, but so do you have any specific requirements in terms of if you have a use case coming on board, or if there's someone who wants to connect to the platform in one of your nodes, that they have to come and do the initial implementation, let's say, or is there anything about that that they should be aware of?
So with COVID, our project was delayed a little bit in terms of supply chain, and especially in our optical equipment. In terms of if people, I mean, do people need to come and do something? Is that the
Yes,
question?
yeah, exactly. Maybe to do a setup of their, their instance on your nodes, let's say.
Yeah, generally with local installations, we've had local installers. We ship the equipment to the site. So for example, for CERN and Bristol, we will ship the equipment, the local IT people. Our plan was to go and do it ourselves. With COVID, they're more than capable. So we will take care of shipping and exporting and all that, and people just need to install it themselves. We have robust instructions. So if you want to connect to us, we'll walk you through it. We'll be on the phone with you, and we will make sure that you get installed and do QA testing with us.
Okay. That's very good. Okay, thank you very much. Any other questions for Anita? Okay, all right, thank you, Anita. Okay, I'm going to go back now and just share my screen again. I thought I had it up before. So the first topic that which Anita presented is the potential of connecting with the nodes as they come on stream in Fabric. Then another topic that we've been discussing is the human-centric and inclusive internet. We don't have a specific topic in NGI per se, but still it covers sort of the human centricity elements of the internet, and checking how the key technologies of NGI could enable measurement methodologies for doing a granular measurement of internet availability, bandwidth, and quality of service, particularly in remote and underserved areas. Deep, do you want to maybe discuss this a little bit? We don't have any slides or anything, but perhaps you might talk about some of the work in the US on this.
Yeah, so again, this is Deep Mehdi from NSF. On open call 5 topics, obviously nothing is finalized yet. We will work with European Commission and Jim Clark to identify NGIatlantic, to identify what topics is going to show. I can see Fabric playing a bigger role by the time, because as you heard just from Anita Nikolic, it's going to be in a much more available state for experimentation. A nice dilemma we'll probably end up having is that based on the list of projects or interests we have received so far, Fabric may end up getting more requests than it might be able to initially handle, but it's a nice problem to have, as I always say. The human-centric and inclusive internet, I want to kind of talk about that, measurement methodologies are going to be very, very important, especially to understand inequity in delivery of services. For example, we are trying to understand a lot better about the broadband access on inequity on where, depending on economic situation, geographic situation, for example, rural areas versus city areas, or core of the city areas, what sort of things are making it more difficult for being able to access internet at a good rate. And so the inequity, obviously plays because of the service delivery part of it, and economics do play a role. So when I think about the human-centric internet there, we really want to be able to more methodologically understand where it is having this kind of issue, rather than having anecdotal comment that, oh, something in city X and Y, they are not being able to get this thing. So I think I really am kind of very interested in the measurement methodologies to be able to find more robust statistical methodologies to be able to identify those kind of things, so that we can actually provide better internet to the community, because we're able to measure it better to be able to then say where the problem is, what sort of things we can go back to event service providers saying that, look, this is what is happening. This is also a fairly large interest to Federal Communications Commission, FCC. But FCC doesn't do research. That's not their job. But they want to understand about what it is going on there. And so we have a lot of interest in that. So I wanted to kind of quickly give you a heads up on those sort of issues that's going to come up in open call number 5. Thanks, Jim.
Okay. Thank you very much, Deep. Did you mention that you are planning to fund some particular projects in this area, or you're already funding something in this area as well?
Are you talking about human-centric part of it, you mean?
Yeah, the measurement methodology.
Yeah, so measurement, we are right now, I'm just telling you guys, don't tell it outside the room. I'm just kidding. So, we are working on creating a new solicitation related to internet measurement. And I cannot give you any update on when exactly it is going to be available, but that's going to have some of those things. So if some folks get funded from that, they will become active award that goes to US-EU collaboration as well. And hopefully that might happen by the time of the deadline for call number 5. So,
okay. And by the way, we're also discussing with the Commission about the possibility of perhaps having a 6th reserve call in 2022.
Oh, right. I remember that. Yes.
Yeah, so that might be a help to this.
That gives you a little bit more time, legroom.
Yeah.
Yep. Good.
So, okay, that's great. Does anyone have any questions about that particular topic, or any ideas they want to tell us about at this stage? No. Okay. Does anyone have any other topics that they want to throw out at this point? That some maybe hot topic that they might think of that we could kind of put into the mix to start talking about. Okay. All right. Well, let me just go back again to this slide because it's really the wrap-up time now. So first of all, I want to thank all of our speakers, for the excellent presentations, and we got a very good mix from both the US and the EU, which was very nice, and on all of the different topics for the Open Call 4. The site for our Open Call 4 is here. We've actually just updated it, and we will be updating it with some more detailed information for each of the topics. At the moment, it's sort of the higher level details, but we will be putting some more details in the coming days. So please check back on that again. Okay. We will also be organizing a webinar, or possibly even 2 webinars in July, which we always do anyway. And if you have any questions whatsoever, please send them by email initially. We have a contact email on the website, which we will then answer within 1 or 2 days maximum. And then if it's a really tricky question, or some challenge you're facing, we do one-on-one coaching calls with their teams. So because we have found in the past that this really helps people a lot more than just looking at an FAQ website. Okay, we do have an FAQ website here. So basically, and this gets updated quite regularly with any new questions that come along. And again, please make contact with us, and we will make contact back with you and try to help you with anything. Okay, and so thank you to everybody, both the attendees and the speakers. We really appreciate all of your efforts in helping us with this important information sharing workshop. And thank you very much to the NSF and also to the European Commission. Okay, so have a great weekend, everyone.